The distribution of the continents and their environments in the world today is a legacy of the geological history of the planet, and of the current climatic zones. Each continent, or zoogeographic realm, has its own assemblage of wildlife. The particular group is determined by the flexibility of the boundaries to that realm, and by periods there was only one zoogeographic realm. The land areas of the world were united as part of the supercontinent of Pangaea has split up into individual continents, and remnants of the original fauna have developed independently in each continent. The animal life in a modern realm may be unique if the boundaries are precisely defined and impassable and have been so for tens of millions of years. On the other hand, the realm may reveal an assemblage that shares many species with its neighboring realm, if the boundaries are ill-defined and easily crossed. Upon the basic animal group in each zoogeographic realm are superimposed the environmental conditions. A single realm may contain tropical forests and deserts, chill tundra and ice caps, and every environmental condition that would fall between. As these conditions are relatively new, having developed throughout the Tertiary period and especially since the Ice Age of the last 2 million years, the varieties of specialized animal on each realm have evolved from that realm's original animal assemblage. The dinosaurs and pterosaurs that developed and established themselves during the Triassic, Jurassic and Cretaceous periods have now developed into browsing, tropical forest types, running and grazing grassland types, burrowing desert types, hibernating temperate woodland types, and migrating coniferous forest types. The shapes of the creatures are quite different from those of the Triassic, Jurassic and Cretaceous periods, but they have all evolved from the same original reptile stock. In the pages that follow we explore the world as it is today. We look at the different zoogeographic realms and see how the combination of geological and climatic changes has allowed the evolution of the huge array of different types of animals. We view the vast and wonderful variety of modern animal life, and in particular, the new dinosaurs. The continent that contains the Ethiopian realm is almost an island. It is joined to the main northern continent only by a narrow isthmus in the northeast. The Ethiopian realm occupies the whole of this area except for a strip along the northern edge. The boundary that separates it from the Palearctic realm in the north is the vast expanse of inhospitable desert that stretches across the continent's widest portion. The Ethiopian continent was once the central portion of the great southern supercontinent of Gondwana. In Triassic times its northwestern edge provided the join between Gondwana and the northern supercontinent called Laurasia, uniting the two in the all-encompassing supercontinent called Pangaea. These two supercontinents became separated during early Jurassic times, by an arm of the sea called the Tethys. Then Gondwana began to break up. The bloc that was to become the Ethiopian continent did not shake itself completely free from its neighbors until the late Cretaceous period, and since that time it has been moving northwards across the Tethys. The Tethys is gone now, closed up by the northward movement of the southern continents. A large island, about 1,200 kilometers long, lies about 700 kilometers away off the southeastern coast. This is a mini-continent in itself, another fragment of Gondwana, and has been isolated for so long that it could constitute a tiny zoogeographic realm on its own. The most mountainous regions lie along the eastern edge of the continent. Here there are mountains that are so high that their summits are snow-covered all year round despite the fact that they lie almost on the equator. Along this edge the forces that tore Gondwana apart are still at work. A rift valley, formed by tension in the Earth's crust, stretches from south to north and shows that the eastern part of the continent is pulling away. Earthquakes and volcanoes are common here, and at some time in the future the whole eastern section of the continent may drift out to join the other continental fragments that are scattered across the ocean to the east. At its northern end this rift valley is already submerged and has formed an inlet of the sea. Other mountains are found along the western coasts. These are the eastern edges of Old Rift Valley that appeared during the days of Gondwana when the continent began to rip itself away from the surrounding landmasses. The rest of the continent consists of flat river basins and plateaus. The habitats of this realm are quite varied, and are arranged in a kind of concentric pattern. The central portion, covering the lowland areas through which the equator passes, swelters as a tropical rainforest. The prevailing winds bring constant rain to this hot area, and the water produces vast rivers that drain from the jungle basins into the sea. This is a zone of small tree-living animals, feasting on the myriad fruits and insects of the lush greenery. To the north, south and east the forest grades into grasslands, where it is still hot, but the rain only falls for one season of the year. Trees do not do well under such conditions but grasses do, and open grasslands and sparsely wooded savanna sweep across the broadest part of the continent in the north, cover the foothills of the eastern mountains, and curve down to the southern hinterland. Long-legged grass-eaters live here, including some strange developments of flightless pterosaurs. To the north and the south lie the deserts, harsh, hot and arid habitats. These are regions that lie along latitudes that receive only dry winds and little rain. The desert in the north, crossing the greatest width of the continent, is so inhospitable that it provides the barrier which effectively isolates the Ethiopian realm. The desert in the south is less extensive but not less antagonistic to life. Yet in the deserts there are animals that have adapted to survive the waterless conditions. Here live tiny, legless, burrowing dinosaurs that have evolved to withstand the extreme killing conditions, and have gone on to be even more successful in less harsh environments. The offshore island was once part of the same realm but must now be regarded as an individual environment. With tropical forest and open woodland, it still supports the kind of animals that existed on ancient Gondwana before it shattered and scattered. Conditions here have not altered significantly since it became isolated, and the animals have therefore not needed to adapt to a changing environment. A whole range of tree-living dinosaurs evolved and established themselves in the branches and boughs of the world forest after the end of the Cretaceous period. They rapidly diversified into all kinds of different forms. About that time the social insects, the bees, wasps and ants, began to develop. These live in colonies, usually consisting of an egg-laying queen sustained and protected by an army of workers and soldiers. The wasp-eaters were a specialized branch of the tree dwellers known as the arbosaurs, that developed at the same time and preyed upon the social insects. After the world forest was broken up by the changing climates and the spread of the grasslands halfway through the Tertiary period, the wasp-eaters became restricted to a number of tropical forest areas. Most species now live in the equatorial regions of the Ethiopian realm. Their long claws are an adaptation to a climbing way of life, and are also useful for ripping at wasps' nests. Their scaly hide has grown into a roof of overlapping plates, impenetrable to the stings of the insects. Similar wasp-eating animals have evolved in the tropical forests of the neotropical and oriental realms. Many of these are related to the Ethiopian wasp-eater, having become isolated in the various tropical forest regions. Others have evolved similar shapes by parallel evolution, the independent development in related animals of similar adaptations to allow them to follow similar lifestyles. The bones of the wasp-eater's skull have become fused into a narrow armored tube that can penetrate deep into the nests of tree wasps. The strong hind legs and tail allow the animal to hang from the branch and reach into nests that have been built in awkward positions. One of the most widespread developments in the dinosaurs after the end of the Cretaceous period was the evolution of the arbosaurs. These evolved from the small coelurosaur theropods, the lightly built running flesh-eating dinosaurs. In Jurassic times the coelurosaurs gave rise to the birds, and the development of the arbosaurs from the same stock was brought about by similar evolutionary processes. Perhaps the most typical of the modern arbosaurs is Arbosaurus itself. Various species of this animal appear in all the zoogeographic realms. The main feature that distinguishes the arbosaurs from other coelurosaurs is the presence of a strong collarbone. In another coelurosaur offshoot, retention of the collarbone allowed for the development of strong flight muscles and paved the way for the evolution of the birds. In the case of the arbosaurs, the collar girdle provides support for the strong arms which are used for climbing and swinging about among the branches. Its endothermic physiology enables it to pursue an active hunting lifestyle. Its skull shows adaptations for this, with the big brain box, the eye sockets directed forwards giving stereoscopic vision, and the narrow, finely toothed jaws, ideal for winkling insects out of crannies in tree bark. An arbosaur, such as the tree hopper, is agile and perfectly at home in the trees, but is a very ungainly animal on the ground. When it is forced to, it can only move over the ground by a series of undignified leaps, keeping its long arms and heavy tail well up out of the way. Most meat-eating dinosaurs have lost their collarbone. They do not need one since the forelimbs do not need to be particularly strong. One or two forms do possess this bone, however, and it is not clear whether their ancestors retained it from the time when they went about on four legs, or whether it re-evolved having been first lost, a process known as secondary development. In Arborosaurus and its relatives, the collarbone provides the anchorage for the very powerful arm muscles with which the animal can brachiate, or swing with an overarm action, through the branches of the trees. An Arborosaur's tail is a stiff, straight rod. It uses it for balance when leaping about among the trees. The long claws on the 3 main toes and the 3 fingers are useful both for finding purchase on branches and for ripping up bark for insects. The tropical grasslands, when they developed and spread halfway through the Tertiary, were a totally novel environment for the great reptiles. Grass is a remarkably tough substance, and a grass-eating animal needs a number of extreme specializations to allow it to survive. Grass is full of hard silica and so it causes a great deal of wear to teeth. A grass-eating animal needs teeth that are constantly growing or frequently replaced. Complex digestive systems are needed to break down and extract nutrients from the substance of grass. On top of all that, a big grassland living animal needs to have long legs to allow it to run away from danger. In some places, such as the prairies of the Nearctic realm, dinosaurs developed quite happily into grass-eating forms. However, on the savannas of the Ethiopian realm, dinosaurs were not able to establish a foothold. They were beaten to it by their cousins, the pterosaurs. A group of pterosaurs abandoned their power of flight as soon as the tropical grasslands spread, and they became the main grass-eating animals of the Ethiopian realm. The lank is now the most highly specialized of these, and the one that has become most unlike its flying ancestor. The body has remained short but the forelimbs and hind limbs have become long and equal in length. The neck and face are also long, all plains living features. The lank runs with a pacing motion, both legs at the same side moving in the same direction at the same time. This prevents the long legs from becoming entangled. The long face of the lank means that its eyes are still above the level of the grass even when its snout is grazing at the grass roots. It can thus keep an eye open for danger. On the open plains danger can be seen coming from afar, and the lank's long legs give it the speed needed to escape from predators. It is difficult to believe that the lank's front legs are evolved from pterosaur's wing. The 4th finger, that once supported the flight membrane, now carries the animal's weight and has a hoof on the end. The 3 small claws that once acted as a hand are now only used for grooming the animal's fine fur. Another of the ground-dwelling pterosaurs of the Ethiopian savanna is the flarp. Its specializations are not so extreme as those of the lank, and its flying ancestry is still evident from the presence of vestigial wings on its forelimbs. It can be thought of as an intermediate evolutionary stage between a conventional flying pterosaur and something as specialized as the lank. Although it lives in the same environment as the lank, the two animals do not compete for the same food. Being much smaller, it feeds closer to the roots of the plants. The lank tends to graze the tops of the grass heads and leaves. The flarp's sharp teeth at the front of the mouth enable it to root about among the plants at ground level. It has fleshy lips and copious cheek pouches enabling it to chew the grass and plants thoroughly before swallowing. After digesting for a while in the stomach, the grass is brought up again for more chewing before being swallowed for a final time. In this way nutrients are efficiently extracted from the plants. The flarp runs about the plains in small flocks of about a dozen and can often be seen displaying their brightly patterned wings, or squatting down in the grass in groups during the heat of the day and chewing over the morning's meal. The structure of the flarp's forelimb and hand is similar to that of a flying pterosaur. The 4th finger is long and supports a flap of skin, the vestige of the flying wing. Now the wing flap is used for display, for attracting mates or for warning rivals. The 4th finger and the flap are normally held back out of the way, but when displaying they are extended and the bright patterns are shown. This display is accompanied by raucous screeches that carry for great distances across the plains. Flarps feed on plants and grasses that grow close to the ground. They have short, sharp teeth positioned at the front of the mouth. Hot deserts are found along the latitudes of the tropics, where air that has risen and lost its moisture at the equator descends and settles dryly over the land. In the Ethiopian realm the deserts are found in the southwest corner of the continent, and all across the north. The northern desert is so vast and inhospitable that it provides the boundary between the Ethiopian and the Palearctic realms. Nevertheless, despite the harsh conditions, there are some animals that do live here. The coelurosaur have proved to be adaptable enough to develop forms that are uniquely suited to such an environment, forms such as the sandal. The days are so hot and the nights so cold that any animal must spend much of its time protected from the extremes. The sandal does this by burrowing in the sand. Its streamlined spindle shape is ideal for a burrowing way of life, since sand grains slide past its smooth contours easily as it tunnels through the dunes, digging and pushing with its stumpy legs. The eyes and nostrils are high up on the head, enabling it to see about and breathe while the rest of the body is buried. Desert animals need to be very careful about water conservation. The sandal never drinks but obtains water from the moist flesh of the animals it eats. Its kidneys are very efficient, allowing almost all the moisture to be retained, and secreting any poisonous compounds in a saliva that helps to paralyze and subdue its prey. The sandal has come a long way, in evolutionary terms, from the agile bipedal, long-tailed coelurosaur that was its ancestor. The body has become streamlined and covered in smooth fur. The clutching hands on the forelimbs and the strong running hind legs have become digging shovels. The scaly head is flat and chisel-shaped, ideal for thrusting its way through the sand as the tough scales prevent abrasion. It feeds on small vertebrates, insects and scorpions. It lies in wait just under the sand, with only its eyes and nostrils showing, and leaps out when the prey comes close. Like the sandal, the WYRM is a streamlined animal adapted to a burrowing existence. It has also evolved from the lightly built coelurosaurs of the Cretaceous Period. Its streamlining takes the form of a great elongation of the body and neck and the total loss of the forelimbs. Its head is trowel-shaped and used to force a path through the sand. There it moves by undulations of the long body and by thrusting with a swimming motion of the broad hind feet. There are many species of WYRM, not all of which have continued to be burrowers. Many live in the burrows of other animals, such as the small desert mammals. Many other have spread into different habitats and different zoogeographical realms around the world. The long sinuous form that first evolved as a burrowing mechanism has applications in other ways of life. There are swimming worms in various parts of the northern Ethiopian realm, where they first evolved, are still burrowing animals, and hunt small mammals and reptiles usually at dusk and at dawn. Like the sandal, they obtain all their moisture from the flesh of their prey, who in turn obtain all theirs from the scrubbly desert plants and seeds that they eat. They make very efficient use of their water despite the fact that they have only one kidney, the other having been lost as the narrow shape evolved. The back of the WYRM is covered with fine hair. The rest of its body is armored by a network of scales. The head is scaly shield. A row of heavy transverse scales runs the full length of its underside, protecting its belly from the constant abrasion of sand and stones as it winds its way along. A heavy shield of scales covers the rump, to protect it from members of its own species that may pursue it down the tunnels of its prey. The WYRM is long enough and narrow enough and agile enough to chase its prey down their burrows. Its diet consists mostly of the small hopping mammals that have evolved to live in the desert. The boughs and evergreen leaves of the tropical forest filter the sunlight into tiny steamy beams that throw a dappled pattern down into the gloom of the jungle floor. This is the domain of the brightly colored birds, the pterosaurs, with their larger wings, being banished to the more open spaces above. Suddenly the raucous chattering of the birds is hushed, and a deep still silence falls in the shadowy forest. The birds have sensed something dangerous. The light indistinct in the sparse undergrowth. With a gasp of air from cavernous lungs, a huge animal rises to its hind feet, pushing itself up on massive legs, steadying itself with clawed forefeet. The great eyes, gummy after sleep and torpor, blink and look around. The huge head contains only enough intelligence to tell the megalosaur that it is hungry again. Slowly it crushes its way through the shadows to the decaying corpse of a plant eater, scattering the scavenging birds and mammals, and resumes the meal that it abandoned days before. Leathery skin. Low intelligence. It is as if time had been turned back to the Mesozoic period when the most important meat-eating dinosaurs were the vast lumbering carnosaurs. The huge island that the megalosaur inhabits lies off the east coast of the Ethiopian continent. Much of the geographical and climatic change that affected the rest of the world have passed this island by, and there has been little impetus for evolutionary change. This island is almost a time capsule revealing what animal life was like on Gondwana hundreds of millions of years ago. The biggest predator of the island is the megalosaur. It is a different species of megalosaur from that which inhabited Gondwana in Jurassic times, but it is still a large and active predator that prowls through the forests, sometimes singly and sometimes in packs, hunting the large plant eaters of the island. As it grows older and slower, it lives as a solitary scavenger, devouring the corpses of already dead animals and the remains of the kills of younger megalosaurs. The classic shape of a carnosaur, one of the large flesh-eating theropod dinosaurs, is retained in the megalosaur. Its sharp teeth and the powerful claws on the forelimbs are used for holding prey and tearing it up. The actual killing is done with great talons on the hind feet. As it walks, the heavy head is held out at the front, balanced by the long heavy tail behind. As the climate and vegetation on the offshore island change little over the 145 million years since it became isolated, the animals that ate the vegetation did not need to change either. The large sauropod dinosaurs, the long-necked plant eaters, have remained practically unaltered over that period of time. The largest is the titanosaur. It browses from the tops of trees. The body is heavy and supported on stout pillar-like legs. The vertebrae of the neck, body and tail are partially hollowed out to cut down on the weight. The tail is usually carried clear of the ground and ends in a whiplash with which it can defend itself against enemies, such as the megalosaurs. Titanosaurs usually travel through the forests in large family groups, browsing constantly from the trees. The continual chewing of new shoots and birds results in trees on this island having naked trunks rising to a height of about 6 meters before the branches start growing. The food is not chewed but passed down into a voluminous gizzard. There it is ground up by stones that are occasionally swallowed by the animal. From there the food passes into the stomach where it is broken down by bacterial action. The gizzard stones wear away quickly and the worn ones are often vomited up and replaced by fresh ones. The soil of the island is littered with small conical heaps of these rounded, discarded stones. There were many families of sauropod in Jurassic times, but it is now only the titanosaurs that survive, and these are found in the neotropical and oriental realms as well as on the island, all fragments of the ancient continent of Gondwana. The skull of the modern titanosaur is almost identical to that of its ancestor of Jurassic and Cretaceous times. It has a steeply sloping face with nostrils at the top of the head and an array of peg-like teeth continued to the front of the mouth. The titanosaur does not chew but merely crops off its food and passes it down to be treated in its gizzard and its stomach. The extremely long tail of the titanosaur is strong and muscular, and can be used as a whiplash to inflict a severe blow upon an enemy. Black and white seabirds flock along the tide mark on the silvery sand, pecking at the seaweed and the dead animals raised up and left by the ocean. Other mode adventurous birds strut about in the dry sand neath the fringe of curving palm trees at the head of the beach. They are being watched from the ridge of red granite that sweeps down from the hilly interior of the island and protrudes as a headland at one end of the beach. Suddenly, from the rounded rocks, a sleek green and orange shape darts onto the dazzling sand and, in a burst and flurry of feathers, one of the more foolhardy birds is caught and killed. The hunter is a tiny megalosaur, similar to that found on the Great Island 1,000 kilometers to the south. It is only about 3 meters long. It picks up its prey and carries it back to eat in peace in the darkness beneath the palms. As Gondwana ripped itself apart and the continents that were to become the Ethiopian and Oriental realms drifted away from one another, many fragments of continental material were left scattered across the ocean in between. One particular fragment is crescent-shaped, about 1,000 kilometers long and is almost totally submerged, but its granite mountain peaks protrude as a scatter of islands about 1,000 kilometers to the northeast of the island of megalosaurs and titanosaurs. Here again the animals are remnants of the old Gondwana fauna, but they are somewhat different, having evolved to cope with new conditions. On a small island there is more limited area. Dwarf forms of animals evolve as the only types that are able to survive the more stringent conditions. The dwarf megalosaur has the appearance of one of the lightly built coelurosaurs, rather than one of the big carnosaurs. It preys on dwarf versions of the plant-eating dinosaurs, but its light build makes it agile and swift, and it can pursue fast-moving creatures, such as the seabirds that flock along the white palm-fringed beaches of the islands. The dwarf megalosaur is a very agile and nimble animal. It usually hunts singly and can prey on the many seabirds that feed in flocks along the tideline. The megalosaur is athletic enough to sprint along the beach and snatch the birds out of the air as they flutter in panic into the sky. The amount of plants available on an island leads to restrictions in the sizes of the plant-eating animals. Dwarf titanosaurs live among the coconut palms of the seashore and in the ferny undergrowth beneath the oaks and pines further inland. They feed on the undergrowth and the leaves of the low-growing vegetation. Unlike their larger relatives, the dwarf titanosaur is not a gregarious animal. It lives in small groups of 2 or 3 rather than in large herds. The group can move quite quickly through the thickets, long necks waving, when faced with an agile predator like the dwarf megalosaur. The body of the dwarf titanosaur needs smaller legs to support it, but the head is as large as that of a conventional titanosaur, and so it looks proportionally large. Dwarf animals are not unique to these islands. Dwarf forms of other large animals live on other islands in the oceans of the world, where a group of animals has become separated from the mainland population. It often happens that the isolated population has no meat-eaters among its numbers. Under these circumstances, small and swiftly moving plant-eating animals may develop into large slow-motion forms, there being no need for speed to escape danger. On an island, therefore, there may be dwarf species of large animals, living beside giant species of small animals. The dwarf titanosaur is very like its large relatives. The main differences are in the slimness of the legs, the weak appearance of the neck, and the shortness of the tail. Like its relatives, it eats forest vegetation which it grinds up in its gizzard with the aid of stomach stones. There are several islands in the group, and the four largest support different species of dwarf titanosaur. These differ from one another very slightly, a reflection of their diets. The Palearctic realm is the largest of the zoogeographical realms, covering as it does the largest continental area on the planet. Historically, the continent consists of the largest part of the supercontinent Laurasia. On its western margin it is moving away from the other large piece of Laurasia, the Nearctic continent, but on its eastern point it remains very close to it. Many times in the past the continents have been united at this point and there has been a free interchange of animals across the isthmus that has formed there. The southern boundary has always been the Tethys Sea, but since Tertiary times other continents have moved northwards and united with it. This collision of continents has thrown up the greatest mountain chain in the world, and this has acted as a natural barrier to migration, so defining the edge of the realm. In the southwest the continent that now holds the Ethiopian realm has not quite united with the Palearctic realm. There is still an inland sea between them. The animal and plant life around this sea is broadly similar to this whole area is regarded as part of the Palearctic realm as well. Most of the mountains of the continent are quite recent and lie along the southern edge and around the inland seas in the southwestern corner, although there are several older ranges. One of these fringes the islands and peninsulas of the northwest coast, and another runs north-south showing where two ancient continents fused together. The habitats of the Palearctic realm tend to run in parallel east-west bands. In the far north is the tundra, a treeless region of permanent chill enlivened by a brief summer. To the south of the tundra lies the largest uninterrupted forest belt on the planet. A vast expanse of coniferous trees stretches from one shore to another. This cold forest is home to a number of dinosaurs that are adapted to feeding conifer needles and cones, and to the dinosaurs that hunt them. Further south again, the center of the continent, far from the sea, is a dry grassland grading into desert towards the barrier mountains. This is the domain of hardy animals like armored dinosaurs. Closer to the sea, by the gulfs and archipelagos of the eastern and western shores, the climate is less extreme, being modified by the regular moist winds from the sea. Deciduous forests grow here, and these support numerous varieties of dinosaurs, pterosaurs, birds and small mammals. The most remarkable animal of the Palearctic realm must be the gestalt. It is unique among the vertebrates because it pursues a communal existence. The gestalt evolved fairly recently, in the Ice Age, when there were few reptiles existing in the western portion of the continent and food was scarce. The animals that did survive there had to develop all kinds of strategies in order to make best use of the food available under the harsh circumstances. The gestalt evolved from one of the smaller pachycephalosaurs, the bone-headed dinosaurs, that lived in herds, mostly in mountainous areas. The gestalt's strategy was to delegate the breeding of the herd to one individual female, freeing the rest to become food gatherers. They developed the ability to build citadels to guard their hard-won food against other animals. Within this hierarchy that is based on age and sex. Now that the Ice Age has passed, the gestalt has found that its evolved way of life is still very efficient and successful. Among the pachycephalosaurs the armored head developed as a display structure, particularly in the males. In the gestalt, the male still has a very specialized head, but it is not used for fighting or intimidating members of its own species. The armor has developed spines containing a lethal poison, now used when protecting the colony from predators. In times of plenty, the population tends to grow too big for the colony to sustain. Small groups of adult males and females then leave to start up new colonies. Streams in the temperate regions of the Nearctic continent may be marked by lines of the conical citadels. The largest individual in the gestalt is the queen. She lays, on average, 1 egg per day all year round. Each egg hatches into a juvenile that is cared for by adult worker females that never leave the colony. When the juveniles, both male and female, reach an adolescent stage, they work outside the nest. Adult females eventually return to the nest and work as nursemaids. They are prevented from coming into a breeding condition by pheromones emitted by the queen. When the queen dies, the pheromones stop and a new queen develops from one of the female workers. The female workers and the queen have very small eyes. They find their way about the gloom of the nest's interior by means of sensory hairs growing from their shoulders. The males are soldiers and have no poison spines that grow outwards from the head shield. They stand guard at the nest entrances, warning of approaching danger by head banging against the branches. Old males may come into breeding condition, shedding their spines, adopting a more subdued color and living inside the nest with the queen. Breeding males are short-lived and are replaced every 10 days or so. The nest is built and kept in repair by the females. It is a thatched structure, built of twigs and straw, usually around a sloping tree trunk over a stream. The interior is a mass of tunnels and chambers, and each nest usually has the same layout. The egg chamber is near the apex where it will be warmed by the sun. The queen chamber is directly below. The nursery chamber, where the hatchlings are tended, is below that. The toilet area is directly over the stream. The food sotra is attached to the main trunk, and there are up to 6 additional food stores on other branches of the tree. Long sticks and saplings are woven into the structure to supply escape routes if the main entrance along the tree trunk is rendered impassable by attack or weather damage. The food of the colony consists of buds in the spring, young shoots in summer, and fruits and nuts in the autumn. The adolescents gather the food, passing it along a chain of individuals from one to another until it reaches the nest. This chain is guarded on both sides by adult males. The deciduous woodlands of the Palearctic realm are found mostly north of the mountains at the western end of the continent, where the continent narrows and few places are far from the sea. It is a region of high rainfall and temperate climate. There are 4 marked seasons: dormant winter, spring in which leaves and flowers appear, summer with the most vigorous growth, and autumn, which is a time of fruiting just before the trees lose their leaves for winter. The predominant trees are oaks, ashes and beech, below which is usually an understory of smaller trees and a thick undergrowth. A typical animal of this environment is the bricket, a small browsing hadrosaur, not similar from its Cretaceous ancestors. In the Cretaceous period there were only the non-crested forms migrated here from further east part of the great spread of the hadrosaurs over the northern continents. The bricket lives in small herds in the dense undergrowth and bramble thickets, usually resting during the day and feeding at dusk and at dawn. The expanded crest, found in both males and females, is both used as a display structure, particularly during the autumnal mating season, and as a deflecting device when it must move swiftly through the vegetation. The long tail of the bricket is used both as a prop, when browsing from high branches, and as a warning flag at times of danger. Stuck straight up in the air, its bright colors warn the rest of the herd of approaching predators. Ticks, fleas and other parasites are easily picked up by thicket-living animals. The bricket has a cleansing ritual that deals with this. A bricket suffering badly from parasites seeks out a piece of fur or a mat of hair that has been lost by another animal on the bramble thorns. Then, holding the fur in its beak, it walks backwards into a river, very slowly, until it is totally submerged, but for its snout. The parasites move up the body, the neck and the head, and are eventually all stranded in the piece of fur. The bricket then abandons the fur and its passengers to the current. There usually follows a period of playful high spirits in the water as several newly cleansed brickets frolic with one another. Mating usually takes place at this time. Further downstream the fur is seized by hungry swims that feast on the parasites. The bricket's streamlined shape is ideal for fast movement through the tangles and thickets of the temperate woodlands. The shape of the crest parts the vegetation as the animal runs, and the slim body allows it to pass between close-growing trees. The brownish color camouflages the animal when motionless, but when it breaks cover and runs it can do so quickly, vanishing at speed into the depths of the forest. In outward appearance, many of the mammals have changed little since they evolved from the mammal-like reptiles in Triassic times. Throughout the Jurassic, Cretaceous and Tertiary periods they have remained small, compact creatures, not adapting into any of the wide ranges of lifestyles occupied by the great reptiles. However, some of them have a number of interesting specializations. The zwim is an aquatic, insect-eating mammal. It inhabits the streams and rivers of the Palearctic realm and is particularly common in regions of deciduous forest. The tail, and the long webbed hind feet allow the animal complete freedom in the water. Its long sensitive snout is used for probing under stones and in dead vegetation for the insects and other invertebrates on which it feeds, both at the bottom of the stream and on land. It lives in burrows on the river banks and can defend itself against predatory reptiles and fish by biting with its sharp teeth. The saliva is venomous and any bite is quickly effective. The zwim is a social animal and as many as a dozen burrows can be found within a short distance from one another on heavily wooded river banks. Large numbers may congregate at the wallowing pools of the bricket in order to feast on the parasites that are shed there. The zwim is an active swimmer, thanks to its webbed hind feet and its flattened tail that works with a strong up and down undulation. The eye is large and it can adjust its focus to see both underwater and on land. The coniferous forest of the Palearctic realms is the largest area of unbroken forest on Earth. It stretches right across the continent along the sub-polar latitudes and, but for the narrow inlet of the sea, would be continuous with that of the northern Nearctic realm. It is bounded by the tundra to the north and the deciduous forests and cold grasslands to the south. The coniferous forests contain relatively few species, compared with other forests further south. The most common conifers are pines, firs, spruces and larches. These reproduce by means of seed-dispersing cones, and it is these cones that provide the food for most of the animal life of the region. Almost the only large animal found here is the coneater, a hypsilophodont that resembles its Cretaceous ancestors. The hypsilophodonts were a very widespread and successful group in Cretaceous times. Lightly built running animals, very much like small iguanodonts, they spread over all the continents before the end of the period. They have continued to be successful all over the world until the present day, occupying a large number of different niches. In the dark depths of the coniferous forest they run in small herds, over the soft undergrowth-free forest floor, and browse in more open country along the river banks. Although the coneater generally eats tree bark, needles, mosses and lichens, and seeks out stores of nuts hoarded by smaller animals. The coneater is an animal of small herds, each herd consisting of about a dozen individuals. Its body is insulated from the intense winter cold by deep folds and wrinkles of fat. Its beak can snip twigs and cones, and its tough food is ground up between batteries of grinding teeth at the back of the mouth. There is not much to eat in the coniferous forest compared with the food available in other parts of the world. Hence there are fewer types of animals here, and each type is very highly adapted for its particular lifestyle. Nowhere is this more evident than in the case of the lynx. The lynx eats coneaters, and nothing else. Its whole physiology has developed to aid this. Since the Cretaceous period, the most successful medium-sized carnivorous dinosaurs have been the dromaeosaurs and the saurornithoids. These are generally lightly built bipedal animals with long, stiff tails, which means they resemble hypsilophodonts in bodily shape. There are differences, of course, especially in the teeth and claws. Both the saurornithoids and dromaeosaurs have a large killing claw on the second toe, obliging them to walk on only their third and fourth toes. This is quite different from the three-toed arrangement of the feet of the hypsilophodonts. They have grasping hands but with only 3 fingers, compared with the 5 of the plant eaters. The meat eaters also lack the characteristic pot belly of the browsers. Nevertheless, the superficial resemblance is so close that one dromaeosaur, the lynx, has adopted a coloration that disguises it as a hypsilophodont and allows it to infiltrate the coneater herds. The deception is so successful that a herd of coneaters may travel for quite some distance without noticing the danger in its midst. The lynx usually hunts in pairs. A pair insinuate themselves into a herd of coneaters as they move through the forest. The lynx's scent glands give off a smell similar to that of its quarry. aiding the disguise. Suddenly, when the herd least expects it, one jinx kills a cone-eater. The rest of the herd, including the other jinx, scatters. When they come together again after the first panic passes, the second jinx attacks and also kills. To the north of the vast belt of coniferous forest that circles the northern hemisphere in the bleaker sections of the Palearctic and Nearctic continents, and the trees give way to a cold region of open landscapes called the tundra. Here the conditions are too tough even for the hardiest of trees, and the vegetation consists of short grasses, mosses and lichens. During the long northern winter, when the sun does not rise for weeks or months at a time, nothing grows. Then, when the bleary summer finally dawns, the winter snows melt away and all the plants grow frantically to best harness the short living season. Animals migrate northwards from the coniferous forests where they have wintered, to take advantage of the sudden harvest of food. They spend the summer months moving northwards, grazing as they go. The largest animal to migrate in this fashion is the tromble, a massive flightless bird that evolved when the tundra regions appeared during the Ice Age. There are no dinosaurs this far north. Even though the dinosaurs developed a warm-blooded system that enabled them to survive a great range of climates, the chill tundra environment was still too extreme for them. The warm-blooded physiology of birds was much more efficient, and therefore the birds were able to move into this harsh ecosystem. Several ground-dwelling birds evolved here since there were no terrestrial predators to threaten them. The tromble, a bird with legs as massive as tree trunks, migrates in huge herds across the waterlogged landscape of the summer tundra above. Eggs are laid in temporary nests at the northernmost point of the migration, and they hatch very quickly with the young able to travel immediately. Its very large body helps to retain its natural warmth. A large animal such as this has a small surface area compared to its bulk, and heat cannot escape easily. The thick coat of hair like feathers helps the insulation, especially during the winters spent in the shelter of the coniferous forests to the south. The beak of the tromble is broad and hard, for cropping great mouthfuls of the coarse tundra vegetation. The food is ground up in the crop with the aid of swallowed stones. Fresh stones are available every year, brought to the tundra surface by frost. The mating season is early summer, when the males sprout bright yellow display plumes. Summer in the tundra reveals not only a rapid growth of plants, but a sudden flourishing of insects as well. Thick black clouds of flying creatures rise from the waters and hover like smoke over the tundra landscape. The mosses and lichens are, for a few short months, alive with scurrying beetles, springtails and mites. Such a harvest of food cannot fail to bring in flocks of insect-eating birds, and huge formations can be seen swooping and diving above the lakes and bogs in the summer. One particular bird has abandoned its powers of flight, leaving the clouds of flying mosquitoes, midges and caddis flies for the airborne hunters, and has concentrated its feeding to the insect life on the ground. Large ground scurrying flocks of whiffles follow the tromble herds, pecking here and there in the stunted vegetation with their long beaks. Through the weight of their passage, the trombles cause such a disturbance to the soil and moss, churning up the mud and crushing down the vegetation in deep footprints, that the insects that live there are sent scattering for new cover. The whiffles following behind are quick to snap them up. Each tromble, representing a huge mass of flesh, is prey to warble flies, fleas and all manner of other parasites which are also eaten by the whiffle flocks. Several species of whiffle are found on the tundra, but they are all rather similar to one another. The body is round and the neck short, to minimize heat loss. Long slender legs enable it to wade in ponds, and the long beak, with the sensitive tip, can probe into mosses and under stones for insects. When asleep, the whiffle can draw its head into the hairy plumage of its body, and hide its sensitive beak among the narrow feathers of its chest. Like most tundra creatures, the tromble and the whiffle are found in the cold northern regions of both the Palearctic and Nearctic realms. In the windswept heartland of the Palearctic continent, the continuous belt of coniferous forest is replaced to the south by cold grassland of mixed grasses and narrow-leaved flowering plants. At the forest edge the grasses are rooted in a rich black soil, but further south the soil is redded and drier. These grasslands are known as the steppe. Beyond the steppe a wilderness of drifting sand, hard-packed clay and shattered stone sweeps southwards to the foothills of the huge mountain chain that marks the southern limit of the Palearctic realm. The steppe grassland is home to many small seed-eating burrowing animals, particularly mammals. Their burrowing way of life keeps the soil churned up and aerated and prevents all the rich topsoil of the surface layers from being used up too quickly. In this way the plant life is maintained. In the spring the steppe is a blaze of color as the flowering plants come into bloom, while in summer the feathery seedheads of the grasses create a totally different landscape. As in most of the great grasslands of the world, the steppe supports a variety of grazing animals, all of which have evolved since the Mesozoic era. The turnitin has evolved from the ankylosaurs, such as Euplocephalus and Cycania, that became so plentiful at the end of the Cretaceous period. The ankylosaurs were divided into two groups. The first were quite lightly built and came to their peak early in Cretaceous times. The more advanced group were heavily built, with massive armor and a weapon on the end of the tail, and were successful after the first group began to decline. Most of the ankylosaurs that exist today are descended from the heavily armored forms. They were always abundant in this part of the world, and fossils reveal that they evolved into grazing animals as the grasslands developed. In the turnitin the armor, developed from horn-covered bones set in the skin, has become a continuous covering for the back. This, and the bulbous shape of the body, help to prevent desiccation in the dry winds. Ankylosaur's armor, consisting of horn-covered bone, evolved as a defensive mechanism. In the turnitin it has become more important as a means of conserving moisture. Hollows inside the skull are lined with damp membranes that moisten the dusty air as it is breathed in. Defensive armor is still present as horny spikes along the flanks and the heavy club on the tail. The head armor of the turnitin is a horny grass-cutting beak along the edges of the broad mouth. Flat teeth in the back of the mouth grind up the plant food. By settling down into a hollow and presenting its streamlined armored surfaces to the wind, the turnitin can withstand the stinging sand and dust storms that are common in the area. The desert of the southern edge of the Palearctic realm are among the harshest environments on Earth. Vast expanses of sand, clay, rock and rubble are baked by a broiling sun during the day and frozen by cold at night. There are no barriers to the chilling winds that blow southwards from the northern icecap, or downwards from the mountain peaks in the south. Rainfall is infrequent and confined to spring and autumn. The vegetation is sparse and only appears when rain has fallen. Animals must be quite hardy to exist in such an environment, and most of the plant-eating creatures found here are cold-blooded. The slow metabolism of such herbivorous animals as tortoises and plant-eating lizards enables them to gorge themselves when the plants are available, and to sleep away the harsher times in burrows. Of the warm-blooded animals, the mammals are most successful, avoiding the extreme conditions by being active only at dawn and dusk. One of the few warm-blooded dinosaurs that live here is the diminutive debril. In its lifestyle and, to some extent, its appearance, it parallels the desert mammals. It is active at dawn and dusk, eats roots and seeds, conserves its water efficiently and burrows in the sand. The debril, like most of the small, plant-eating modern dinosaurs, is descended from a hypsilophodon ornithopod. It is well adapted to the extreme of its environment. Under cold conditions it hunches itself up to present a small surface area to the wind. The wrinkles in the skin bunch together to form an insulating coat. Heavy lids fold over the eye to prevent chilling. During cold conditions it moves in a series of bounds. When it is hot it stretches itself out, presenting a large surface area that is easily cooled, and travels by running on hind legs. The Nearctic realm consists of an roughly triangular complex of continent and islands, reaching from the desert latitudes in the south to the polar ice cap in the north. At its broadest it runs along the Arctic Circle, where it consists of glaciered mountains and icy islands in a frozen sea. To the south, in its more habitable zone, it is a continent 5,000 kilometers broad, but this narrows rapidly to an isthmus connecting it to the neotropical realm in the south. Much of this isthmus is desert, and provides the barrier between this realm and its neotropical neighbor. The continent once occupied the western part of the supercontinent of Laurasia. It was in this region that the two supercontinents, Laurasia and Gondwana, were almost permanently united in the days of the world continent of Pangaea. It did not split away from the continents that were to become the Ethiopian and the neotropical realms until late Jurassic times. At about this time, too, it broke free from the remainder of Laurasia, as a new ocean opened up between it and the rest of the supercontinent to the east. Since then, land connections with other continents have come and gone many times. In the northwest, the most westerly portion is separated from the most easterly point of the Palearctic realm by the shallowest and narrowest of seaways. Throughout its history, this seaway has dried out and flooded again each time, allowing animals to cross from one continent to another. At the moment it is flooded and forms the boundary to the realm, but that will only be a temporary state. Likewise, to the south, the isthmus between the Nearctic and Neotropical continents is a very temporary affair, breaking and reuniting many times in the past, and each time having an effect on the migration of animals. At the moment the connection is complete, but that may not be for long. Topographically, the continent consists of new mountains in the west, old mountains in the east, and flat plains between. The western mountains are still building up, due to the movement of the oceanic plate there, and earthquakes and volcanoes are frequent. The whole of the northern portion of the continent, much of it submerged and only appearing as islands, consists of hard, old Precambrian rocks, the kind that form the nuclei of all continents. The southern half of the lowland section consists of a vast river basin draining to a gulf in the south. The habitats range from frigid cold to searing hot climates. The far north is still in the grip of the Ice Age, with continental glaciers smothering the great northeastern island, and pack ice choking the straits and inlets. Where the land is not ice-covered, it consists of tundra, bleak and only habitable for a few short months of the year. Even if the land bridge between the Nearctic and Palearctic realms were not currently broken, these conditions would prove just as impenetrable a barrier between the two areas. Further south lies a vast belt of coniferous forest, almost a continuation of that region found in the Palearctic realm. The animals there are similar to those in the Palearctic forests, as there was a clear connection between the two realms until very recently. Deciduous forests lie to the south of this and clothe the older mountain ranges found in the east. Here, the tree-living animals, particularly the arbosaurs, are superficially similar to those that live in deciduous forests elsewhere. They have been separated from them for so long, however, that these arbosaurs are of totally different species. The western third of the continent consists of mountain ranges, high and elongated, with desert valleys and plains between them. Both plant-eating and meat-eating dinosaurs have adapted to the sparse food supplies in the high reaches. The central lowlands, drained by the vast river system, is a region of temperate grasses. The grass is long and lush by the rivers but becomes shorter and sparser as the land dries out and rises towards the western mountains. Hadrosaurs, evolved originally to live in lush forest, now roam these open prairies. Having adapted successfully to a grazing animals, comes the evolution of carnivorous hunting animals. Low-lying lands around the southeastern corner of the continent, where the land has only recently risen from the sea, and the vast deltas produced as the huge river empties into the gulf to the south, have given rise to a unique series of water-living animals. Here are dinosaurs that hunt fish, and pterosaurs that strain tiny invertebrates from the shallow water. There is even a hunting dinosaur that demonstrates a cunning intelligence unparalleled in the dinosaur world, to enable it to eat swift-flying creatures such as birds and pterosaurs. The prairies, the grasslands that spread out across the center of the Nearctic continent from the Great Winding River on the lowland plain to the towering wall of the massive western mountains, support vast herds of grazing animals. The most widespread of these are the sprintosaurs, evolved from the duck-billed hadrosaurs of the late Cretaceous. In the last 65 million years, as the forests gradually gave way to the grasslands, the hadrosaurs evolved to adapt to the changing habitats. Like the hadrosaurs before Therm, there are two main groups of sprintosaur, the crested, and the non-crested. The crested sprintosaurs tend to inhabit the western high prairies, grazing the short grasses and undergrowth of prickly pear cactus in the dry shadow of the mountains. In the long evenings of the mating season, the thin upland air resonates to the shrill trumpeting sounds as the sprintosaurs call to one another, using the hollow crests as sounding tubes. The crests are formed from the bones of the nose. They probably evolved to extend the nasal passage and allow dry air to pass over moist membranes before reaching the lungs. They successfully perform this function, because the air of the high prairie is very dry. Distinctively shaped crests are found in different species of crested sprintosaur and serve to distinguish members of one species from another, as they roam the sparse grasslands below the mountain ramparts. Both males and female sprintosaurs possess the crest. Crests vary from species to species and are used as signaling and identification devices. The shapes range from hook shapes, as in Anchoracephalus major, through rows of knobs, as in Sprintosaurus quadribolus, to broad blade shapes as in Sprintosaurus dolobratops. The sprintosaurs evolved from the duck-billed dinosaurs of the Cretaceous period. These, in turn, evolved from completely bipedal dinosaurs but began to spend more time on all four legs. When they evolved into the plains-living sprintosaurs, they became completely quadrupedal. The legs are long and lightweight, with muscles concentrated in the thighs and upper arms, and the tail, having lost its balancing function, has degenerated either to a stump or to a flagpole. The non-crested sprintosaurs, like their slightly larger crested cousins, evolved from the hadrosaurs. However, while the crested forms evolved from such crested hadrosaurs as Corythosaurus and Parasaurolophus, the non-crested forms evolved from the flat-headed line of the hadrosaur group that included Hadrosaurus and Edmontosaurus. Since Cretaceous times, their evolution into a grassland animal was parallel to that of the crested sprintosaurs. The cropping beak and the huge battery of constantly replaced grinding teeth needed little modification to suit a diet of tough, silica-rich grasses. As their faces were permanently in the grass, eating, the animal adopted a four-footed posture. On the open plains danger can be seen from a long way off, and so the legs became spindly and lightweight to enable the animal to run swiftly from harm. The face became long to keep the eyes above the level of grass so that a lookout could be kept for predators while grazing. The main difference between the non-crested and crested sprintosaurs, apart from the crest, is the presence of the tail. Having lost its function as a counterbalance, necessary when its ancestor went about on two legs, the tail has become a tall, stiff flagpost. The males have a fin of skin supported by bony struts at the tip, and this is used for signaling. Different species have different sizes and patterns of fin. The non-crested sprintosaurs live mainly on the long grass, lowland prairie where the adaptations of the particularly long face and the tail flag are of most use. The sprintosaurs, both crested and non-crested types, travel over the plains in closely knit herds. Vexillosaurus levips is a non-crested sprintosaur from the floodplains of the Great Central River. It moves about in tight herds, often only seen as a bunch of tails waving above the long grasses. When a predator such as the northclaw attacks, the herd breaks up in a confusing flurry of flags and poles, leaving the attacker bewildered. Puma-like, the northclaw slinks through the grasses of the prairie, its tawny stripes blending it into the dry yellows and browns of the vegetation. Its reptilian eye is fixed on an unconcerned grazing group of crested sprintosaurs, its instinctive cunning guiding it towards the most effective attack. For long hours its sleek body moves, slowly but surely towards the unsuspecting herd. Suddenly a male sprintosaur, looking round, notes something in the grass that does not quite fit. He trumpets out a warning blast and the herd scatters in a cloud of dust. With an instant reflex the northclaw darts up from its place of hiding and arrows down on the slowest of its prey. Its powerful hind legs thrust the horizontal body forward, balanced by the stiff rod of a tail. Then, when almost upon the young sprintosaur, which is still deciding which way to run, the single long claw springs out, hooks into the skin and pulls the animal over, kicking and struggling in the dust and the grass. Another blow of the claw and the prey is disemboweled, and the northclaw settles down to feast. The northclaw is a coelurosaur, one of the more lightly built theropod dinosaurs and, apart from its large head and furry coat, it differs little from its Jurassic and Cretaceous ancestors. The main difference is the massive single claw, the killing organ on its right forelimb. The lightly built sprintosaurs are not the only grazing animals that roam across the vast prairies. Huge slowly moving grass eaters also exist here, cropping the grasses down to their roots and moving on in black dusty herds. The huge monocorn is one of several species of ceratopsian that still inhabit the Nearctic continent. It differs in appearance from the member of its ancestral stock, such as Triceratops and Styracosaurus, but the differences are not really profound, and they are a reflection of the life that the animal now leads. The herds of monocorn need to be on the move constantly, for once all the grass in one area is eaten up they have to move on to fresh areas. The legs are therefore longer and more slender than we would expect in such a large animal. The feet are digitigrade, that is they support the weight of the body on the toes rather than on the flat of the foot, the plantigrade condition of the monocorn's ancestors. In common with the ancient ceratopsians, the neck and shoulders are protected by a bony frill, and a horn on the nose is used as a weapon. The ceratopsians are now no longer confined to the Nearctic continent. Several species are now found in the Palearctic realm where they spread via the land bridge between the Nearctic and Palearctic continents before the Ice Age. The horn of the monocorn is a formidable weapon when turned on an attacking carnivore like a northclaw. Monocorn herds usually travel with big males on the outside protecting the females and hornless young. Its bony frill is very long, covering the length of the neck to the high shoulders. It is used when males spar with one another for herd leadership. The constants push harmlessly against one another until one tires and gives way. The tangle of braided mountain chains in the western third of the continent is relatively new, thrust up to its present height only in Cretaceous times. The open river plains of the Jurassic and the steamy forests of the Cretaceous period, the habitats of the most prolific dinosaur communities in the past, are now craggy mountains, clothed in glaciers and now. A few dinosaurs adapted to this new environment, moving in from the regions round about and adopting a lifestyle that would support them there. Balaclava is one of the most specialized modern hypsilophodonts. It evolved insulating layers of fat and fur, an ability to eat the alpine plants and mosses, and a compact shape to preserve its body heat. The balaclava lives in small family groups in the highest mountains. It can often be seen trekking across snowfields and glaciers from one lichenous rock or mossy hollow to another. It can subsist on a very poor diet. Layers of fat insulate the balaclava, and the hairs on the tail and feet help it to grip icy surface. Its broad beak and the spade-like nails on the three middle fingers enable it to scrape up lichens and moss, while the longer claws are used for digging up alpine plants. The intelligence that gradually developed among the coelurosaurs enabled them to adapt to all kinds of harsh conditions. The large brain of the mountain leaper coordinates its movements, and enables it to make swift judgments as it springs and leaps between the spires and crags of the mountain peaks, hunting the birds and small mountain mammals on which it feeds. It has developed a high degree of endothermy, warm-blooded, to help it to cope with the icy climates, and the thick shiny fur is indicative of this, providing the insulation that keeps the animal's body at a constant temperature. The head and body reach a length of about 1 meter, but the flowing hair, the long legs and long balancing tail with its spectacular plume make it look much larger. Mountain leapers live in small packs, with the males undertaking all the hunting, and protection of the females and the young. When not hunting, the male mountain leapers stand as motionless sentinels, guarding the females and the young of the pack. On bright days the pack may run itself on the open slopes, at which time it is vulnerable to attack by birds of prey and mountain pterosaurs. They are agile and swift when traversing the mountain peaks. With sure-footed springs and leaps they move rapidly, maintaining balance with the long tail. In the midst of the southern deltas of the Nearctic continent there lives one of the most cunning of the dinosaur hunters. Descended from the Saurornithoids, the springe has a similar size and proportion to its ancestors. Its head, however, has expanded and now contains a larger brain, and the killing claw is carried on a particularly long second toe. With its naked skin mottled a deathly white and pink, and the matted, dark-patterned fur, the springe has a derelict, morbid appearance. The springe is the most cunning of the hunting dinosaurs. Its Cretaceous ancestors were the most intelligent animals of the time, and this trait has continued through evolution. The intelligence has evolved for a simple purpose: to find food more efficiently. The hunting strategy of the springe is one of ambush. It lies on a tidal mudbank, in an attitude of rigor mortis, with its head and tail thrown back and its hind leg pulled into a stiff pose. It inflates its belly, showing off the death-like mottling, and emits a smell like that of putrefaction. This performance is irresistible to the carrion birds and scavenging pterosaurs of the swamps who flock to the site. A swift dart of the killing claw and a victim is impaled. A great tract of land on the southern and southwestern shore of the Nearctic continent consists of deltas, swamps and backwaters. Since Cretaceous times it has gradually been rising above sea level, and it is now covered in marshy vegetation, comprising vast areas of reed beds and mangroves with stands of conifers, evergreen oaks and magnolias on the drier banks. The available moisture and warm climate mean that several varieties of plants and animals live here. Bird and pterosaur life is particularly abundant, as the birds have adapted well to this pleasant environment. Ducks graze the waterweed, divers plunge into the waters after fish, and waders peck after small creatures in the mud and shallows. However, the pterosaurs live side by side with the various species of birds and reveal similar adaptations to the same conditions. The open skies above the swamps and lakes are usually filled with wheeling flocks of birds and pterosaurs, particularly at dawn and at dusk in the evening. At a distance, pterosaurs like the sift can be distinguished from birds in flight by their comparatively larger wings. The sift feeds on the tiny plants and animals that abound in the shallow waters of the deltas. Shrimps, worms and little fish are stirred up by the long-toed feet and caught with the narrow jaws. Floating algae and weeds are strained from the water by the fine teeth. As on all the other continents, the arborsaurs fill the trees of the Nearctic realm. Some eat insects, others consume fruit and berries, and some prey upon other arborsaurs. The treepounce is one such carnivore and tends to be less agile than its relatives. However, what it lacks in agility it makes up for in stealth. Lying along a branch on a sunny day, its spotted coat makes it almost invisible in dappled sunlight. With infinite patience it waits until an unsuspecting nagar, or smaller arborsaur scrambles close, and then pounces, making a quick kill. The treepounce relies mainly on its hearing for hunting, and so its ears are highly developed. Tufts of hairs around the ear opening funnel the sounds into the ear canal. In appearance the tufts resemble the fleshy external ears found on some smaller mammals. The coloring of the coat conceals the treepounce in the trees. In the deciduous forests of the Nearctic realm live a vast variety of different arborsaurs, each one specifically adapted to a particular way of life. One of the most highly specialized is the nagar, with its wood-boring jaws and its long thin finger. It feeds almost exclusively on the grubs of wood-burrowing beetles that it hunts in the living wood. Of the bristles on the tail give it a firm grasp on the tree while it listens for movement beneath the bark and drills into the wood after the larva. If there were no dinosaurs living, it is possible that some of the ecological niches now occupied by tree-living arborsaurs would have been occupied by birds. It seems entirely probable that a bird could have evolved to fill the niche of the pecking arborsaur, with a strong bill taking the place of the powerful teeth, and possibly a specialized tongue doing the work of the long finger. The second finger of the nagar is remarkable, being about as long as the forearm. It is used for poking down burrows and winkling out the larvae of the wood beetles on which the arborsaur feeds. A hooked claw at the end secures the catch. Its skull is perfectly adapted to its purpose of drilling into solid wood. The teeth grow only at the front of the jaw and are directed forward, each one lending support to the one before. Those at the very front bear the brunt of the pecking force. When they wear out or break, they are replaced by more teeth growing in from behind. The neck joint is very strong, protecting the back of the skull and the brain and giving support to the heavy neck muscles needed for the constant rapid pecking. The trees are alive with myriads of tiny insectivorous arborsaurs, each on differing from the next by the different colors of the pelt, by different display tufts on the head and tail, and by slight differences in the shape and size of the head. The arrangement of the skull and jaws depends upon the diet. Feeding both in the trees and on the ground, the tiny arborsaurs have short, thick jaws to crunch up beetles, or long thin jaws to dig for buried larvae and worms. All the arborsaurs have the same light build, long, springing legs and thin toes. The body is small and balanced for running and jumping by the long, stiff tail. The foodle is a typical narrow-jawed arborsaur. The body weighs only a few grams. It is a very agile little creature, scampering along boughs and leaping from branch to branch with ease. The long legs enable the foodle to leap nimbly through the treetops. The 3 fingers and 4 toes, all long and thin, can perch on, and grasp, the thinnest of twigs, while the long jaws can root around under the leaves to catch insects hidden there. Many species of foodle live in the forests of Nearctic realm. The continent containing the Neotropical realm is almost an island, connected to the Nearctic continent by only the narrowest necks of land in the northwest. The realm includes the northern land bridge last established about 5 million years ago, and the southernmost tail of the Nearctic continent proper. It is the barren desert conditions found here that decline the barrier between the two realms. In the very south, a compact string of islands connects the continent to the vast frozen continent that lies over the South Pole. This continent has so little life on it that it does not constitute a zoogeographic realm. The Neotropical realm was once the western part of the supercontinent Gondwana. This is obvious from the shape of the eastern coastline, which follows the shape of the western coastline of the Ethiopian continent exactly, showing where the two became separated in the Middle Cretaceous period. Its separation from the Nearctic continent in the north was not so complete nor so final. Both the Neotropical and Nearctic continents have been moving continuously towards the west, overriding the oceanic plates there. The relative plate movements along the western coast of the two continents has meant that there has been a continual steady buildup of fold mountain chains and volcanoes along the western coasts. This buildup has continued in the ill-defined region between the continents as well, and over the millennia island chains and land bridges have been created across the sea channel, and then destroyed again. At the moment, the connection is present in the form of the land bridge in the west and a loop of volcanic islands in the east. As with the other continents, the physical geography reflects the geological history. There are old mountains in the east, representing one edge of the old Rift Valley along which the Ethiopian continent tore away during the Cretaceous period. Along the entire western coast there is a new mountain range, constantly being enlarged by the reaction between the continent and the plates of the nearby ocean. Volcanoes buble and stream along the length of this mountain range. The isthmus that connects this continent to the Nearctic continent can be thought of as the northward continuation of this range. Two main river basins are found in the lowlands. Most of the northern reaches of the realm, being within the tropics, are clothed in tropical rainforest. The huge river basin found in the broadest section of the continent is fed by the daily rain that falls here. As in most tropical forests, the favorable growing conditions mean that thousands of species of trees grow here, supporting many different kinds of tree-living animal, from the insects to the tree-living dinosaurs that feed on them. The forest floor has its own fauna of insects and insectivorous dinosaurs. To the south, the largest areas of the lowlands are occupied by grasslands, that range from tropical in the north through temperate and then cold in the south. On these pampas live grass-eating animals, huge long-necked grazing dinosaurs like those that have existed on the continent throughout its life as an island realm. These dinosaurs are becoming rare and even extinct now, and are being replaced by other creatures that are evolving from animals that have migrated south from the Nearctic realm. As the western mountains provide the land connection between the Neotropical and the Nearctic realms, it is hardly surprising that many of the immigrants to the realm have evolved from Nearctic mountain animals. Many of those coming south have developed into forest-living and pampas-living types. Some, however, have remained mountain creatures. Some of the largest pterosaurs in the world soar above these wild mountain chains. There are deserts here too. The grasslands in the very south are extremely dry. They are in the rain shadow zone of the mountains, where the prevailing winds drops all their rain on the other side of the ranges. Coastal deserts are found in a narrow strip between the mountains and the sea. Here, the cold ocean currents cause the air to cool and descend so that no rain falls. Further south on this coastal strip, however, there are moister, more fertile conditions where the wet winds blowing from the ocean have more influence on the climate than the cooling by the ocean currents. An interesting example of the re-evolution of features once lost, arises in the cases of the pangolin. Its body is covered in scales, but these are not the conventional reptilian scales that were possessed by its archosaurian ancestors 200 million years ago. These scales are actually plates of fused hairs. The original scales were retained as of the archosaur evolved into the primitive coelurosaur dinosaur. Then, as the coelurosaur, the scales evolved into insulating fur. The pangolin, which is evolved from an archosaur that has reverted to a ground-dwelling way of life, has redeveloped a scaly armor from masses of fur fused together. Its ground-dwelling habit evolved as the ants flourished and became widespread in the early part of the Tertiary period. As the ants evolved, then so did the ant-eating adaptations of animals like the pangolin. The typical, long toothy jaw of the arborsaur have been replaced, in the pangolin, by a tubular snout, along which lies a long sticky tongue that can be thrust out to a distance greater than the length of the head. It can push its snout down ant burrows and lap up the ants that adhere to the tongue's stickiness. The middle claw of the forelimb has developed into a strong hook that can tear into ants' nests to expose their tunnels and chambers. The nostrils are high up on the face, can be closed for protection. The pangolin has a long sticky tongue which it extends into ant burrows. The dense scaly armor of the pangolin is not a protection against ants but guards against attacks by predatory reptiles that live on the tropical forest floor. The pangolin is a slow-moving animal and unlike its relatives, it cannot that refuge in trees. When it is threatened, the pangolin can curl the paddle-shaped tail beneath its body to protect its soft underparts from the stings and biting jaws of the large ants. The waters of the vast network of channels and tributaries that pour into the Great River flowing eastwards along the equator are alive with aquatic animals of one kind or another. The forest reaches over the quiet bayous and backwaters, steeping them in a murky green gloom. Water plants root in the deep mud, reach upwards through the turbid waters and spread their leaves out over the placid surface. The undersides of the floating leaves support colonies of water snails and other aquatic invertebrates, and these are eaten both by fish, and by lightly built animals that crawl over the tops of the leaves and probe downwards. The floating leaves themselves are eaten by huge, placid, slow-moving water beasts that swim lazily in the shallows and engulf huge mouthfuls of the vegetation. The largest of these river browsers is the water gulp, evolved from the swift-footed hypsilophodonts that were so successful in Cretaceous times. The powerful hind legs have since evolved into paddles, as have the versatile five-fingered forelimbs. These are used mainly for stabilizing the animal's great bulk, and the two claws on the forepaddles are useful for grubbing around the muddy roots. Most of the swimming action is achieved by the tail. The stiff rod-like tail of the ancestral hypsilophodont has become more flexible, and a tall leathery fin along the upper surface can produce powerful swimming strokes. The evolution of the legs and tail of the water gulp mean that it can move only in water. Its eyes and nostrils are high on the head, allowing it to see above the water surface when submerged. The mouth is broad, and the sharp-edged horny beak can cut through the stems and leaves of the toughest water plants. It is one of the largest river animals. Each water gulp also supports a large colony of parasites and other companions that feed on algae growing on its flanks, and on small creatures disturbed from the mud by its passage. As in many aquatic vertebrates, the water gulp's ribs are very heavy, giving it enough weight to keep it submerged. It also swallows stones from time to time to adjust its buoyancy. As in tropical forests all around the equator, the trees of the neotropical realm are full of numerous kinds of animals. They support many more different types of animal than the trees of the forests in the temperate or cold zones. With the constant high temperatures and the daily rainfall, vegetation flourishes and several hundred different species of tree thrive in a very small area. A thick canopy consisting of intermeshed boughs of the tallest trees spreads out to catch the sunlight. Epiphytes and dangling creepers festoon these high branches. As a result, there are many different kinds of leaves, flowers and fruits available above the gloom and roots of the forest floor. Many varieties of animals have evolved to exploit these potential foodstuffs. Generally, the tree-living animals of the neotropical realm are smaller than those of the tropical forests in the rest of the world. The airy canopy is alive with little arborsaurs adapted to feed on the thousands upon thousands of different types of insects that make their homes there. Some of the arborsaurs, however, have abandoned their insectivorous way of life and have evolved into totally new forms. The nectar-sucking gimp, for instance, is a tiny animal with a slender delicate head, and eats nothing but nectar. Its snout has evolved into a long tube which acts as a rigid sheath for an extendable nectar-gathering tongue. These features are similar to those of the ant-eating adaptation of the pangolin, and it is likely that both animals evolved from the same group of arborsaurs that crossed from the Nearctic realm early in the Tertiary period. The tubular snout may be seen as an example of pre-adaptation where a feature evolves spontaneously and is then retained because it is perfectly suited for a particular purpose. The nectar-eating gimp feeds rather like moths and bees, pushing its snout down into the base of long flowers to reach the nectar. As a result, the snout emerges covered with pollen which the gimp then unwittingly transfers to another flower, thus fertilizing it. The animal's shape is similar to that of the small arborsaurs, but it is not as fast-moving. Its forelimbs can grasp flower stems. Its body is very small, since nectar needs very little digestion and requires only a small gut. Many species of gimp exist in the neotropical forest. Each one eats the nectar of a particular species of flower and has a correspondingly different shaped snout. A more obvious difference between species is the pattern on the back. This can range from spots, to stripes, or large patches of color. Bright flashes of color appear in the heights, up among the branches, creepers and trunks of the neotropical canopy. To and fro, the colors dart, like large butterflies, swooping and wheeling in the breezes, then flopping onto a branch and blending instantly with the mottled bark in the dappled sunshine. These are not butterflies, however, but some of the smallest dinosaurs that have ever existed. Descended from the same coelurosaur stock as the arborsaurs, the scaly gliders adapted to a gliding life with the evolution of the flowering plants and hence, the butterflies. The latter represent the glider's principal food. A controlled dive and glide through the air can bring a scaly glider close to a butterfly at rest on a flower, and, with a quick snatch of pointed jaws, the insect is caught and the glider sails on to rest and digest. Flying and gliding animals frequently evolve in tropical forests. With the network of massive boughs and close-growing branches, animals can easily jump from one tree to another. The more aerodynamic the animal's shape, the further it can jump. The conditions are perfect for the evolution of gliding structures that can carry an animal over even longer spaces. In the case of the scaly glider, these structures consist of broad scales projecting sideways from the body. In flight, they turn the animal into an aerodynamic skimmer, while at rest, they help to camouflage it against the tree bark. They are brightly hued beneath, but drab when seen from above. The scaly glider has a set of paddle-like scales, growing horizontally from each side of the body and spreading out to form gliding wings. Muscles in the flanks and attached to the ribs give the scale some limited mobility, allowing the bright undersides to be exposed or hidden at will. It is the smallest and most lightweight of all the dinosaurs. Throughout their evolution, the sauropods seem to diminish in size. They reached their largest size in the late Jurassic, and then, towards the late Cretaceous, a number of small forms appeared. This trend continued until there were a number of quite lightweight sauropods in the neotropical continent in tertiary times. Some were quite fleet of foot and would run gracefully in herds across the pampas. The neotropical continent has had an interesting history. After it had broken away from the ancestral supercontinent, it remained an island continent for most of its life. It connected only occasionally to the continent of the Nearctic realm in the north, as it is today. At the end of the Cretaceous period, the duck-billed dinosaurs spread over most of the continents and established themselves as the principal large herbivores, replacing the great four-footed sauropods. The sauropods still exist, but mostly in places where the duckbills never gained a foothold, such as the neotropical continent. Isolated from the influences of migration from other continents, the sauropods evolved in their own way. The Titanosaur family, the only surviving family of sauropod, had begun to develop armor as early as the late Cretaceous period. They continued to do so in the neotropical continent and, in the late Tertiary, with the arrival of the new meat-eaters, the armor developed into very flamboyant and spectacular forms. The Turtosaur has a solid shield of armor over its back and flanks. The tail and neck are also shielded, the tail by overlapping rings of horn, and the neck by jointed horn sections. The head is covered with a continuous horny shield. The jaws have no teeth, but the mouth edges of the horn shield are sharp and are ideal for cropping grass. The armor of the Turtosaur is formed from bone masses that grow in the skin and are covered by a layer of horn. The back armor is a solid mosaic of small skin bones, with much larger bones spread between them. These larger bones provide the bases for a series of conical spikes. Huge hump bones and shoulder bones support the weight. There is no armor on the legs or the underside of the tail. When danger threatens, the animal flops down on its belly and presents an impenetrable shield of bone and horn to its enemy. Isolated from the influences of migration from other continents, the sauropod of the neotropical continent evolved in their own way to cope with such changing conditions as the spread of the grasslands. The lumber is a grassland living sauropod that has evolved from a tree browser into a grass grazer. During the Tertiary period, many strange grassland-dwelling sauropods developed to live in the newly evolved pampas, including a number of long-legged, running forms. These were very vulnerable to the swift-footed carnivorous dinosaurs that spread across the continent about 4 million years ago, when the present land bridge was established to the Nearctic continent to the north. The long-legged sauropods were fast runners, but they were nowhere near as fast as the meat-eaters and were eventually made extinct. The sauropods that survived did so because they evolved defensive strategies. The pterosaur, for instance, evolved armor. Others, such as the lumber, took refuge in mere size. The lumber is the largest land animal alive today. It cannot raise its neck far above its shoulders, but it can sweep round and reach vast areas of grass without moving its feet. Its teeth are confined to the front of its mouth and are hard-wearing, adapted for cropping grass. The trunk helps to pull bunches of grass towards the mouth, where they are torn off and swallowed. The skin is thick and leathery, quite resistant to meat-eaters' claws and teeth, and most carnivores leave the huge creature well alone. The long neck and the trunk of the lumber enable it to graze over a large area without moving far. The neck is quite stiff but can be swung from side to side at the shoulders. Towards the head it becomes more flexible. The teeth are confined to the front of its mouth and are adapted for cropping grass. The muscles of the short trunk are anchored on broad plates of bone at each side of the enormous nostril opening in the skull. The trunk is a feeding organ used to grasp and uproot large bunches of grass. It is also a breathing organ, but the position of the external nostrils do not interfere with its feeding action. Many animals flooded into the neotropical continent about 4 million years ago, when the string of volcanic islands linking with the Nearctic continent to the north fused to form a land bridge. The animals quickly evolved and developed to fill the ecological niches they found. In most instances, the animals that come south were more successful and began to replace the indigenous animals that had dominated the continent for the previous 50 million years. The reason for this may be that the indigenous animals had evolved few variations in that period of time. The continent itself had not shifted substantially and there had been little change in the environment and the climate except for the spread of the grasslands. There was no necessity then, for the animals to evolve, and they had settled into a long period of decadence. The animals from the north, on the other hand, had suffered millions of years of CNAGE, with changes in climate and interchanges of animals with the Palearctic realm, and had been evolving vigorously. When they reached the neotropical continent, they were more able to adapt to the conditions found there and, as a result, the native animals suffered. The most noticeable instance is found among the meat-eaters. The first of the northern animals to reach the continent were the mountain leapers. Being skilled at traversing high mountain ranges, they were well able to cross the mountainous neck of land that connected the two continents and spread into many of the ecological niches. Large meat-eaters quickly developed from this stock and preyed on the swift-footed sauropods of the plains. Even larger types developed, some with their heavy heads and small arms, looking as if they had evolved from the great carnosaurs of the Cretaceous period rather than the small agile coelurosaurs. One such as the cutlasstooth, which has evolved huge cutting teeth that enable it to prey on the large sauropods like the lumber. Hunting in packs, cutlasstooth can set upon a lumber and slash it until it bleeds to death. The cutlasstooth's dental arrangement is unique among dinosaurs. The first tooth of each upper row is a long, curved slashing weapon. Those behind it are continually growing. Once the front tooth is broken and discarded, there is another to take its place. Its jaws can open remarkably wide, so that the lower jaw is well away from the cutting teeth when the heavy head is thrust downwards in the slashing stroke. The undersides of the large teeth are serrated and work against the lower teeth as carnassial blades for ripping and chewing flesh when the animal is eating. When hunting, a pack of 4 or 5 can inflict deep bleeding wounds on the flanks of their prey, and then wait until it bleeds to death. During the last 4 million years, many of the meat-eating dinosaurs that were unique to the neotropical continent were destroyed during invasion of the more versatile creatures from the north. The Tyrannosaur family of carnosaurs that developed in late Cretaceous times were the largest of the meat-eating dinosaurs, although some of the spinosaurs approached them in size. As they became larger, their heads became heavier and their forelimbs became increasingly smaller. They spread through the areas that now constitute the Nearctic and Palearctic realms, but they have long been extinct in THSES regions. A group of tyrannosaurs did manage to filter into the neotropical continent when the land bridge was temporarily in place about 55 million years ago, and there they survived while their relatives died out elsewhere. The line of their evolution continued and they increased in size. The gourmand is a massive creature, the forelimbs have atrophied entirely, with no trace of either limb bones or shoulder girdle in the skeleton. As the tyrannosaurs grew huge, they became too heavy and slow to hunt. They developed a scavenging mode of life, a life now led by the gourmand. The small forelimbs of the ancestral tyrannosaurs were used to steady the animal as it arose from its belly after resting on the ground. In the gourmand this is unnecessary since the hips have moved forward to balance the body perfectly. The legs are jointed in such a way that they lift the body straight upwards off the ground. The animal is a scavenger, moving slowly across the pampas and swallowing whole the carcass of any dead animal it discovers. The skull is very flexible and the jaws can unhinge to enable it to engulf its prey. Once it has eaten, the gourmand rests for several days while it digests its meal. It does this while lying motionless in the grass. The armor protects it from predators during this period. The slow-moving gourmand is protected from other meat-eaters by a back armor of bony plates sheathed in horn. Its scavenging lifestyle is very different from that of its ancestors. The Western Mountain Range that forms the backbone of the neotropical continent traps moist air blowing in from the ocean and is always drenched in rain. The precipitation produces streams that cascade steeply back to the ocean on the western side, or form small rivers that develop into the tributaries of the huge rivers that meander across the lowlands to the east. These streams are full of different types of fish and invertebrates. The fish are eaten by various animals including birds, pterosaurs and specialized hunting dinosaurs. One of the most interesting animals is the dip, a fish-eating dinosaur evolved from the coelurosaurs. Like many of the hunting dinosaurs of the neotropical continent, the dip is descended from the mountain leaper that migrated southwards when the land bridge to the Nearctic continent was established about 4 million years ago. It retains the long silky fur of its ancestors that is necessary to protect it from the harsh mountain climates. The head has evolved the shape that has developed in many groups of fish-eating animals. The jaws are long and narrow and furnished with many fine pointed teeth. The eyes are set so that they are directed forward and give stereoscopic vision. Like the mountain leaper, the dip is very fleet of foot and can run acrobatically along the sides of crags to escape the predatory birds and pterosaurs that abound in the region. The dip is a patient animal and sits by the pools of mountain waterfalls waiting for fish. It is able to judge its distance from its target despite the distorting effect of the water, and darts its long head downwards, cleaving the water and pinning the slippery fish between its many sharp teeth. Between the mountain peaks and above the valley of the western mountain range soar a number of large birds and pterosaurs. They circle in the winds rising from the valley heads and the updrafts from warm hill slopes. One of the largest of these soaring creatures is the harridan, a pterosaur. It can maneuver expertly while in flight. The air sweeping over its broad wings is controlled by additional membranes attached to the second and third fingers of the hand. These two fingers are elongated but not as much as the fourth finger that in all pterosaurs supports the main flying membrane. The first finger carries a claw which is used when the animal is crawling on cliff faces. Its head is almost mammal-like, with an elongated snout and sharp teeth at the front. The eyes are directed forward and give a good stereoscopic vision. This pterosaur is a solitary animal. It mates for life and nests on high pinnacles in the mountains, rearing no more than 2 young each year. With its warm-blooded physiology, and its carnivorous hunting habits, it is very similar to the predatory birds that are found in the mountainous areas of other realms. The harridan has very keen eyesight and can spot small animals scampering about on the ledges hundreds of meters below. It then swoops out of the sky and pounces accurately on its food. Its prey usually consists of the small mammals that have adopted a mountain habitat. The harridan is a mountain pterosaur, evolved to soar in the mountain air currents. It is equally at home on the ground, however. The wings and legs membranes can fold away when it is at rest and the harridan can walk about the crags and ledges like any other biped. With its keen stereoscopic vision, it can accurately swoop down and snatch unsuspecting small animals living on the ledges far below the mountain peaks. In addition to the wing membranes, it possesses membranes on its hind legs. Each of these is supported by a very long first toe, and is used to control the animal in flight. The Oriental realm is the smallest of the zoogeographic realms, and in many respects, it is the most difficult to define. Geographically it is part of the Great Northern Continent and is that section of it that lies to the south of the huge barrier of mountain chains that crease up its southeastern corner. However, it also encompasses the cluster of jungle peninsulas and volcanic island archipelagos that reach out across the ocean towards the Australasian realm in the southeast. The most extensive flat area if the realm is a triangular peninsula consisting of an old fragment of Gondwana. Most of the rest of the realm is quite new and is formed of fold mountains. The northern boundary is well defined by the ramparts of the mountains. To the west, the boundary lies in a desert region that is continuous with that in the north of the Ethiopian realm. The southeastern boundary is not well defined. It lies somewhere in the sounds and straits between the strings of islands. Many animals can move from one island to another by swimming across the intervening sea areas, or by drifting on mats of vegetation, or even by walking across when the sea level permits. Some Australasian animals have penetrated well into the Oriental realm in this way, and many Oriental animals have similarly spread into Australasian territory. It is difficult to place a realistic boundary between the two realms here. The fragment of Gondwana that formed the main peninsula did not break away from its southern supercontinent until the late Jurassic. Since then it has moved northwards across the ancient Tethys Sea, out of the southern hemisphere and into the northern, and eventually collided with the northern continent as recently as 30 million years ago. The rapid approach of one continent to the other crumpled up the seafloor sediments between them, and the final collision crushed these up into the greatest mountain range on the face of the Earth today. The disturbance caused by this collision was widespread. Its ripples produced the mountain ranges to the east, those that reach out their crests into the sea to form the peninsulas. The oceanic plate that carried the PIECR of Gondwana northwards is still forcing its way beneath its neighbor, and producing the chains of volcanic islands that lie between the northern continent and that of Australasia. In geological terms, this area is constantly changing. The Oriental realm is one of mountains and islands, and its habitats reflect this. It is something of a zoological crossroads, many of its animals having arrived from neighboring realms. Deciduous forest and wooded grasslands lie on the Great Triangular Peninsula. These are grazed and browsed by the descendants of the old Gondwana fauna, big long-necked plant-eaters that are only found on the other fragments of the Gondwana supercontinent. These share the plains with creatures more typical of the Palearctic and Ethiopian realms that have moved in and adapted well to the environment. The rivers that pour off the mountain ranges produce lush, forested deltas where they flow into the broad bays of the ocean. The deeply indented coastline means that there are few permanent ocean currents and the river sediments can build up into huge deltas here. Trees, such as mangroves, that can withstand flooding by both fresh and salt water, establish themselves on mudbanks and trap more silt by their root systems, so building up more areas of land along the coasts. The forests receive heavy rainfall during the summer months because of the monsoon climate. The warming continent to the north produces rising air masses that draw in moist winds from the sea. In the winter the opposite is the case and dry winds blow outwards from the arid interior. The forests and deltas are home to thousands of different tree-living and aquatic dinosaurs, many of them evolved from creatures that originated in the Ethiopian, Palearctic and Australasian realms. The mountains to the north are the highest on Earth. They are also some of the steepest. Height mountain peaks and glaciated ridges can drop to tropical forested ravines and valleys within a few kilometers, passing through narrow zones of alpine plants, and rhododendron and bamboo forests on the way. The alpine plants found at high altitudes are browsed by nimble-footed dinosaurs browse the steamy forests in the deep valleys. Deserts lie in the west, defining the boundary to the realm. Across these have traveled a number of dinosaurs adapted to arid conditions, which have then gone on to develop quite easily into forest dwellers. During the Tertiary, a large triangular piece of ancient Gondwana moved northeastwards across the Tethys Ocean and fused with the northern continent. It threw up the greatest mountain range on Earth along the join. The Gondwana anmeal life continued on this new triangular peninsula with litha change, isolated from the northern continent by the mountain range. The largest animal now on the subcontinent is the rajafant, evolved from the Cretaceous titanosaurs. It wanders in small herds, grazing the yellow grasses of the Central Plains. Although its physical appearance has not changed very much from that of its ancestors, it has developed a complex social structure for life in the exposed grasslands. It has also evolved a feeding mechanism that allows it to eat tough grasses as well as the soft leaves of the bushes and trees. The mouth is broad and the teeth are sharp enough to crop grass, but not strong enough to chew it. The grass is swallowed in vast quantities and collects in an enormous muscular gizzard, a meter wide, in the forward part of the stomach. There it is pounded and crushed to a digestible pulp by masses of hard stones that are deliberately swallowed by the rajafant from the time of time. The rajafant herds have evolved defensive habits and take great care to protect their vulnerable young against the predators. The adults cluster round and lash out at the swooping hunters with their long necks and teeth, and their heavy whip-like tail. The open plains and grasslands are visited by many species of predatory birds and hunting pterosaurs, that soar and circle in the hot skies searching for likely victims. Anything moving on the exposed ground is a potential meal. Each rajafant herd has a strict social structure, and this is especially evident while the herd is on the march across the grasslands in the rainy season. Out in front is an old bull, the undisputed leader of the herd. The younger bulls march along the flanks in a defensive formation. The females shepherd the calves in a knot in the center of the herd. Up towards the snowline of the greatest mountain range on Earth, the range that divides the Oriental from the Palearctic realm, there is very little to support life. Yet even these bleak regions have a number of highly adapted animals. The hanuhan is a dinosaur that has evolved to live in these harsh conditions. Its adaptations are similar to those of the balaclava, deep layers of fat for insulation, and strong claws and beak for scraping the sparse plant material, mosses, lichens and alpine plants, from the rock's craniers. Like the balaclava, too, it has evolved from the successful hypsilophodonts of the Cretaceous period. As such, it has probably come into the Oriental realm across the vast mountain range from the Palearctic realm, rather than having been brought up from Gondwana in the south on the drifting continent. It is a very nimble animal, sure-footed on crags and confident on the narrowest of ledges. The brain has developed well to control balance and muscular coordination. It could be that the hanuhan evolved from tree-living hypsilophodonts before developing adaptations suitable for its mountaineering lifestyle. The hanuhan lives in small family groups, usually scattered over a wide area of mountainside. The food is so sparse at altitudes of about 4,000 meters that larger concentrations of animals would not survive. The agility of the hanuhans enables them to move from one bleak pasture to another with ease, hopping and leaping from rock to rock, balanced by the stiff rod of the tail. Well below the snowline, beyond the bare rocks and sparse alpine plants that are the habitat of the hanuhan, the mountains fall away, slope after slope, into the lower flanks and the foothills. On the slopes that reach downwards from about 4,000 meters to the misty regions of about 2,000 meters, the climate is equable and the vegetation more prolific. In the higher reaches the alpine meadows give way to rhododendron scrub, and then to belts of bamboo forest. The greater variety and volume of plants means that more animals live here than further up. One of the largest of these is the taddy. Another descendant of the hypsilophodonts, probably from the same stock as gave rise to the hanuhan, the taddy is a slow-moving forest animal that feeds almost entirely on bamboo shoots. Several species and subspecies of taddy exist in the bamboo thickets, each one being isolated from the others on particular ranges of foothills. It is a large and heavy animal, unlike its hypsilophodont ancestors, and is able to maintain its slow way of life in the absence of ground-living predators in the rhododendron and bamboo forests. The large size of the taddy and its lazy appearance makes it quite different from its agile hypsilophodont ancestors. The five-fingered hand that was too typical of the hypsilophodonts has been retained in the taddy. The small first and fifth fingers have become versatile and opposable, acting as small thumbs that can fold over the palm. The resultant hand is able to firmly grasp the bamboo stems which are taddy's main food. The Great Mountain Range is young, but it is already deeply weathered and eroded. Annually melting snows from the higher slopes and the constantly decaying glaciers produce torrents of water that form streams cascading from the heights towards the distant plains and ocean. At the same time, the mountain range is continually pushed upwards by the inexorable movements of the Earth's crust. As the mountains rise, the river gorges deepen. This has led to an unusual circumstance, in which a major eastward-flowing river on the northern flanks of the range has turned south and cut right across the mountain system to reach the sea in a mass of deltas to the south. Cutting through the range, it has formed a gorge supports its own wildlife. The most typical animal is the numbskull, one of the pachycephalosaurs, or bone-headed dinosaurs. It has changed very little since the group evolved in Cretaceous times, and it still pursues the same herbivorous lifestyle. It lives in herds and family groups in the river gorge, with the males periodically sparring with one another for leadership of the herd. The numbskull is bipedal and roams through the tropical forest found in the gorge, maintaining balance with the strong tail. The late Cretaceous period pachycephalosaurs spread worldwide. Many developed into new forms to exist in new environments, but some, like the numbskull, remained quite conservative. The bulk of the lowland areas of the Oriental realm consists of tropical forest. The climate, known as a monsoon climate, supports forest habitats. During the summer, the constant heat over the northern continent gives rise to low-pressure areas that bring moist winds in from the ocean that lies to the south. A rainy season ensues. During the winter, the continent cools and dry air blows out towards the ocean. The mainland forests thrive in this seasonal rainfall, but the forests of the island chains to the southeast receive the wet winds all year round, both northerly and southerly winds blowing over sea areas before reaching them, and are particularly luxurious. Tree life is abundant, and many species of treeworm exist in the tropical forest. The treeworm is directly descended from the desert burrowing worms of the Ethiopian realm. Although the sinuous shape developed in response to a burrowing lifestyle, it became suitable for many other ways of life. The extra centipede, and allow the animal to crawl up very steep slopes. The bulbous body is pushed along behind by the hind legs. The treeworm feeds on small insects and vertebrates. The distribution of treeworms is widespread, especially in the tropical forests of the Oriental realm, the animals having moved there across the deserts that form the boundary to the realm to the southwest of the Great Mountain Chain. The treeworm feeds on arboreal insects and small vertebrates. It can hunt these with its stereoscopic vision and can catch them with rapid flips of its long neck and snaps of its jaws. At rest, treeworms lie along boughs or dangle like creepers. The insides of their hind legs have an arrangement of strong scales angled inwards, allowing them to grip branches firmly. As in all other tropical forest areas, the tree-living animals of the Oriental realm have evolved into a vast variety of strange forms. Many of these have developed from the arbosaurs of the other realms. The tropical forests here support an extensive range of plants, and so there are many different kinds of insects and plant-living creatures found in the forest. They in turn become prey for a wide variety of carnivorous and insectivorous animals. One insectivorous animal that is found only in the forests of the eastern islands is the gliding arbosaur, the fleuret. Most arbosaurs are able to leap great distances from branch to branch and from tree or tree, in order to look for more prey. The fleuret evolved as gliding habit from these beginnings. Flaps of skin, or patagia, between the forelimbs and the body, developed and became aerodynamic structures. These do not allow the animal literally to fly, but they enable it to glide from one tree to another. The fleuret's glide path has an angle of descent of about 45 degrees, which can be controlled to some extent by the positions of the arms. When not in use, the patagia fold away against the animal's sides and do not interfere with its hunting. Like the other arbosaurs, it feeds mainly on insects which it catches by winkling them out of their tree burrows with its long fingers. Different species of fleuret are found on other islands. They are distinguished from one another by their markings. The wings, or patagia, of the fleuret, although not allowing it to fly as a pterosaur's wings would, enable the fleuret to glide for great distances between the trees. Its hollow bones help to keep down the body weight. It can control its gliding flight path by altering the position of its arms and by swinging its long tail. When hunting or feeding below, the fleuret folds its patagia away. The fleuret is very small. The underside of the wings has a very bright pattern, invisible when the wings are folded, and this is used for display and intimidation. Its nervous system is highly developed in order to coordinate the movements of its flight and keep it under control. Vast areas of tropical swamp and deltas are found in the Oriental realm, where great rivers, fed by the snow and glaciers of the mighty mountains, wander across the lowlands and empty into the ocean. Mangrove swamps develop at the sea's edge on the mudbanks built up by debris deposited by the rivers. The mangrove swamp usually blends into the tropical forest on the drier land, and many of the tree creatures that live here are the same as those further inland. The swamps are home to a great many fish and aquatic animals, particularly those that can withstand the conditions of both salt water and fresh water. They also support vast numbers of wading birds and pterosaurs that feed on the fish and the mud creatures. The parasaur is one of the oddest of such animals. It is a pterosaur that hunts in the shallow lagoons and backwaters of the swamps. The wings are brightly colored and make a dazzling display as the pterosaur launches itself into the air and flies off over the swamp. The wings, however, have another function. They are used as a kind of a trap in order to lure and catch fish in a way that is totally unlike any other in the animal kingdom. The parasaur, unlike other fishing pterosaurs, is a solitary animal, flying and hunting on its own. Its head and jaws are very slim, with many tiny sharp teeth. These teeth are typical of a fishing animal, being able to grip slippery fish firmly. Demonstrating its unique fishing action, the parasaur wades in the open shallow waters and holds its wings out in a huge fan in front, casting a large shadow over the water. This has two results. First, the fish actively seek out this welcoming shade to escape from the glare of the sun, and second, the parasaur can see and catch the fish without the distracting reflections on the surface of the water. A very specialized plant life grows in the waters of the mangrove swamp. It must be able to withstand inundation by muddy fresh water at times of flood, and by salt water at high tides. It must also be able to grow in the shifting muds brought down by the rivers. The mangroves can do this, securing their roots in the mudbanks to anchor the sediments and build them up into permanent parts of the landscape. The roots often protrude above the level of mud and water to help the plant to breathe, there being little oxygen in the mud of the swamp. In the water there are many other varieties of plants, and these are consumed by a number of different animals. The largest is the glub, a descendant of the adaptable hypsilophodonts. It is similar in appearance to the water gulp of the tropical river swamps in the neotropical realm, also evolved from a hypsilophodont. The resemblance is a case of parallel evolution, in which two related creatures have developed along the same lines in response to similar environmental conditions. The evolution took place independently, on opposite sides of the world. In the glub, the process has gone even further than in the water gulp. The whole body of the glub has become a swimming organ. Sinuous, lateral movements of its body and tail, aided by the tall fin down the back, drive the animal forward through the water. It steers itself by its forelimbs. The hind limbs have totally atrophied. The glub is totally adapted to life in the water. Its eyes and nostrils are on the top of the head to allow it to see about on the surface while the body is submerged. The front legs have paddles and a long claw for digging up the roots of the water plants on which it feeds. Of all the paleographic realms, the Australasian must be the most isolated and self-contained. The vast proportion of its bucks is a single island continent, straddling the southern tropic. Other portions of the realm consist of several large and thousands of smaller islands scattered to the north and east. Some of the eastern islands are even more isolated than the main landmass and could be regarded as small, individual zoogeographic realms of their own. The islands to the north consist of continuous archipelagos reaching towards the great northern continent and the Oriental realm. The history of the Australasian realm is quite simple. Up until the late Cretaceous period, the continental area was part of the southern supercontinent of Gondwana. During that time, rift valleys appeared and plitted away from what is now the South Polar continent. Ever since then it has been moving northwards, and in the past 50 million years or so it has moved from the southern polar regions into the tropical latitudes. This represents the fastest of all the continental movements since the split up of the supercontinents, and during this time there was no mixing of animal life from the surrounding regions. The animals present were the remains of the old Gondwana faunate, a so-called relict fauna, and these have had to change continually over the past 50 million years in order to adapt to the changing latitudes and climates. The animal life found in the Australasian realm is therefore quite unique. Over the past few million years, however, the continent has been approaching the offshore islands of the Great Northern Landmass, and there has been some influx of animals from the north. There has also been a constant pressure from the oceanic plates to the east and the north, and as a result, island chains have formed, producing an offshore fringe of archipelagos around the main continent. The movement has also given rise to the only major mountain chain on the continent itself, and this runs up the length of the eastern coast, from an island in the south to a tapering peninsula in the north. The remainder of the continent is a vast flat plateau, over half of which is more than 300 meters above sea level. The largest of the neighboring islands consist of mixtures of old continental rocks, fragments of Gondwana, and new rocky material folded up from the seabed by the plate movements and forced through by new rocks emplaced as volcanoes. The habitats of the main continent are dominated by the position of the continent across the southern desert belt of the planet. Hot air that rises and drops its rain into the rainforests at the equator spreads north and south at high altitudes and cools. At these latitudes it begins to descend and, being dry, produces arid and desert environments on any land mass that lies below. The center of the Australasian continent is primarily desert, surrounded by dry grassland. Here live dinosaurs, that can subsist on the poor grasses and dry scrubby bushes of the arid regions. Where an oasis of water appears, the invertebrate and fish life that thrives in it is exploited by specialized dinosaurs and pterosaurs that have evolved here are found nowhere else in the world. The coastal regions, particularly in the north, are more fortunate. Wet winds from the sea bring a milder and more equable climate to these areas. In the north, the forests that are produced are almost tropical jungles while, elsewhere, eucalyptus forms the characteristic woodland that clothes the eastern mountains and the coastal plains. Tree-living animals range from omnivorous arboreal dinosaurs that feed on fruits, nuts and shoots, to very specialized feeders that subsist on a diet of eucalyptus, unpalatable or poisonous to most other creatures. The islands to the north are clothed in tropical forest, being surrounded by warm ocean. The islands to the east also have a wet climate, supporting forests of various kinds, although wide areas of grassland exist supporting a unique fauna of terrestrial grazing pterosaurs. These have developed in isolation, and they parallel the grazing pterosaurs that have evolved independently in the Ethiopian realm. The more widespread oceanic islands are not technically part of the Australasian realm. They appear during volcanic eruptions and, once cooled, they represent completely fresh habitats ripe for colonization. Once vegetation is established on an island, the animal life arrives. The islands are isolated and so they are usually inhabited by descendants of flying creatures that have crossed the oceans by air. The island habitats are fully exploited by creatures like birds of pterosaurs that have given up their powers of flight. The rivers that drain from the Eastern Mountains into the arid hinterland of the Australasian continent often seep away into the desert, or else from lakes. Lakes that form in the rainy season support an explosive burst of algae and crustaceans, and the crybrum feeds on these. Coelurosaurs have been present on the Australasian continent at least since Kakuru hunted there in early Cretaceous times. It would be from a creature such as this that the crybrum evolved. In build it is rather like a conventional coelurosaur, but the long curved jaws are armed with thousands of tiny, needle-like teeth. These strain living creatures from the fine mud and water of the deltas and lakes. An unusual feature of the crybrum is that it changes color depending on where it is feeding. When it is feeding in the fresh water of the streams, the color is a light gray. When it feeds on crustaceans and algae in the salty waters of the lakes, however, its skin and hair turn pink. The red coloration in the algae is concentrated in the bodies of the crustaceans that feed on it, and thus appears in the pigmentation of the crybrum that feed on them. The crybrum stands in the shallow water, often on one leg, and feeds by sieving the water through its finely toothed jaws. It swings its head around in a wide arc to cover as much water as possible. There are few predators on the shores of the salty lakes, but when one does appear, slinking down to the water's edge to try and trap an unwary crybrum, the herds panic and scatter in all directions. The milling surge of pink distracts and confuses the hunter, while the voluminous curtains of spray thrown up by the dash through the shallow water conceals the direction of the fleeing herd. Wherever fish are abundant there will be fishing animals, including, on occasion, dinosaurs. In fact, fishing dinosaurs, such as baryonyx, existed in early Cretaceous times. The rivers of the Australasian continent, however, have a unique group of fish-catching dinosaurs called the pouches. These generally belong to the same genus, Suchosaurus, and have evolved from the coelurosaurs. They are quite amphibious, being happier sculling about on the surface of the water and diving to the river banks. The nests are built of mud and sticks, above the local flood level. The eggs, hatchlings and juveniles resemble those of a totally land-living creature, suggesting that it has not been long since the pouch evolved from a terrestrial ancestor. The swimming habits of the young pouches must be learned at their parents' side while their bodies develop the aquatic adaptations of adulthood. In the water, the adult pouch swims gracefully on the surface, with its striped tail waving as a flag. It moves steadily with powerful strokes of its webbed hind feet and dives swiftly after fish, steering with a membrane between the forelimb and the body. The catch is held in a bag of skin beneath the lower jaw until the pouch returns to land. Fish caught by the parent pouch are stored in the bag beneath the jaw. There they are kept safe while the dinosaur waddles up to the nest and presents them to the young offspring. Several species of pouch exist in the rivers of the Australasian continent. Many live together and the species are distinguished by the different patterns of color on the tail. The webbed hind feet and steering membrane of the pouch enable it to swim easily through the water. Diving swiftly beneath the surface, the pouch seizes a fish between its sharp teeth. The interior of the Australasian continent is very dry. Almost two-thirds of its area is desert or dry grassland. It is a harsh environment for living things, but not an impossible one. Many animals exist here, but the only large one is the guana. It is the last survivor of a widespread plant-eating dinosaur group, the iguanodonts. These dinosaurs were closely related to the hypsilophodonts, the descendants of which are now found all over the world, but the iguanodonts tended to be much larger, had more cheek teeth. On all the other continents of the world the iguanodonts were eventually replaced by the more versatile hadrosaurs, but in the Australasian continent they survived in isolation as the hadrosaurs never reached that landmass. The larger number of cheek teeth meant that the iguanodonts were in a better position than the hypsilophodonts to evolve into grass-eaters when grassy plains developed in the mid-Tertiary period. The grasses of the region are not particularly nutritious and a large animal has to range further to find enough to eat. The guana lives in small family groups which can move quickly from one area to another seeking fresh pastures. The physical build of the original iguanodont was quite suitable for this way of life and it has not changed dramatically. At rest, the guana is on all fours, with its head near the ground. When moving, it is a bipedal animal. Its longer hind legs can bear its full weight, and its body is balanced by the heavy tail as it walks or runs across the open landscape. The guana lives in family groups of 4 or 5 adults and a number of young. The sparse grasses could not support larger herds. Their sandy color camouflages them from a distance. They move mostly by walking or running, but when faced with sudden danger, such as finding a poisonous dingum in the grass, they leap out of the way, flashing their flank patterns as a warning to others. The guana has evolved mouth parts that can deal with tough grasses. A solid horny beak at the front of the mouth crops the grass. It is then pulled by the tongue to the cheek pouches where it is chewed thoroughly by a series of constantly replaced grinding teeth. The brightly colored head crest is used for signaling during the mating season. The hand can be used for walking, for grasping and for fighting. Like a big lizard, the dingum creeps through the grasses of the hot, central Australasian plains hunting small mammals, reptiles and insects in the dry tussocks. Suddenly a dark shadow sweeps across as a hunting pterosaur hurtles down from the sky. In an immediate reaction, the dingum arches its back and dips its head. A fin of skin supported by struts of bone springs up from its curved back and presents a gaudily colored sail to the attacker, a sudden burst of garish color against the drab grasses. The crest on the back of the head pops up a frill of spines, each one poisonous enough to kill a large attacker. The pterosaur breaks off its attack, instinctively knowing that these colors mean danger and death, and flies away to seek easier prey. The dingum is small for a dinosaur. It is descended from the coelurosaurs, the small meat-eaters of the Mesozoic era and, like many other Australasian animals, lives nowhere else in the world. It is a meat-eater but occasionally eats small poisonous plants. The dingum itself is immune to the poison, which is then concentrated in the spines at the back to the head and used in defense. The female is quite a different animal, however, having neither poison spines nor sail. It is much larger than the male and has a more conventional coelurosaur shape. It is more secretive in its habits, avoiding predators by not being conspicuous. The dingum's complex mating and nesting ritual begins during the wet season. The male begins to build its nest from clay, and the half-built nest is used as a display area while it courts a female. After mating, the couple continue to build. By the dry season, the nest is completed, with the female walled up inside incubating the eggs while the male hunts food. In the next wet season, when the eggs have hatched, the male stands guard at a newly enlarged nest entrance while the female hunts. The bright colors of the male dingum's crest and sail worn would be predators of its poisonous nature. High in the luxuriant branches of the tropical forest trees in the northeast of the Australasian continent, a black and white creature throws itself from one branch to another and disappears among the foliage. At first glance it looks like an arborsaur, one of the 3 living coelurosaurs that are found all over the world. Then it appears again, and its bright face, surmounted by a high crest, is its most obvious feature. This is a crackbeak, a tree-living descendant of the successful hypsilophodonts. Crackbeak ancestors were lightly built running animals, evolved to run swiftly across open country. Now the legs have developed into jumping legs, and the lightweight feet have evolved for perching. The small first toe has turned round to face the rear, so the foot can now be used for grasping branches. The tail is still a long, stiff balancing organ but can now be used as a third leg. Pressed against a tree trunk, it gives animal a firm anchor while feeding. As in the arborsaurs, the crackbeak has developed a strong system of bones and muscles in the shoulder region to help it climb trees. The front feet have become dexterous hands. Crackbeaks are found in many other parts of the world, particularly in the tropical rainforests of the Ethiopian and Oriental realms, but it is only on the Australasian continent that they are so abundant and varied. The superficial resemblance in size and shape between the Australasian crackbeak and the arborsaurs of the northern continents has come about by convergent evolution. They both evolved from lightly built running ancestors and have become lightly built tree-dwelling animals, but whereas the arborsaurs subsist on a diet of insects and small vertebrates, the crackbeak is strictly vegetarian. The crackbeak's bill is delicate enough to pick individual berries out of a bunch, yet powerful enough to crack open even the hardest nuts. The beak is used only for picking and cracking, the actual chewing is done by the back teeth. The horny crest on the head, along with the bright color of the face and dewlap, are used for signaling both to mates and to enemies. The crackbeak hand, like those of all hypsilophodonts and most of their descendants, has a full complement of 5 fingers. All the fingers are long and mobile. Both the first and the 5th fingers are opposable, or able to cross over the palm of the hand in order to grasp things. These are very useful to the crackbeak while climbing in the branches and selecting food from between the twigs. Not all tree-living animals are active jumpers. Up in the topmost branches of the eucalyptus trees of the southeastern and southwestern corners of the Australasian continent lives a silvery blob. This is the tub, a clumsy-looking creature moving sluggishly up and down the silvery-gray branches of the eucalyptus trees, feeding on nothing but the bluish foliage. At first glance it is difficult to imagine that both the tub and the crackbeak are evolved from the same hypsilophodont ancestors, yet there are clues. The hind feet have 4 toes, the first of which point backwards and allow the animal to grasp branches. The hands have 5 fingers, the outer 2 of which are opposable. The deep head has powerful jaw muscles and a sharp beak, for breaking off food from the trees. The other physical features, however, are quite different. The body is round and not suited for rapid movement. The legs are more suited for grasping trunks than for swinging along branches. The tail is short and stubby. It is the 2 opposable fingers on the hand that reveal the tub to be closely related to the crackbeak. Of the hypsilophodont descendants in other parts of the world, only the tati of the Oriental realm possesses this feature. The tub's rotund shape is unique. There is no other animal like it anywhere. It probably evolved from the hypsilophodonts that were present on the Australasian continent in the Mesozoic period. The related crackbeaks must have evolved there as well, and spread on the Oriental realm along the island chains. It's a placid animal, moving slowly and eating nothing but eucalyptus leaves and twigs. It has neither armor nor speed for defense. Its only protection from enemies, such as birds and pterosaurs, is in its distasteful flesh. Its body tissues store up the poisons that are present in the leaves and bark that it eats. A pair of islands lies about 2,500 kilometers to the southeast of the main Australasian continent. Together they are more than 1,500 kilometers long, and so are strictly too large to be considered islands yet too small to be true continents. Geographically they contain elements of both. They consist of pieces that were once part of the main southern continent of Gondwana, yet much of their area consists of new material produced by volcanic action since Gondwana woke up. With such a turbulent history and such an isolated position, it is hardly surprising that the animal life found here is unique. Very little remains of the fauna that existed when these fragments were part of the great supercontinent. It lives near the north coast and has remained unchanged since Triassic times. The bulk of the animal life consists of birds and pterosaurs, many of the latter flightless. These evolved either from flightless pterosaurs that were already on the continental fragments when they broke away, and so may be related to the flightless pterosaur of the Ethiopian grasslands, or from more conventional flying pterosaurs that flew to the islands and then abandoned their powers of flight. The clune is a typical terrestrial pterosaur of these islands. It has no wings, or indeed any trace of the forelimbs that it must have possessed at one time. It is covered in thick shaggy hair and lives secretively in the undergrowth of the forests, eating low-growing plants. The clune, a vegetarian, has continually growing, gnawing teeth at the front of the jaw, and broad grinding teeth at the back. This is totally unlike the tooth pattern of the ancestral pterosaur. In absence of predators, it has adopted a totally terrestrial way of life. The forelimbs, with the wings, have disappeared completely and the hind limbs carry the weight of the whole body. The original 4 toes of the pterosaur foot have remained. The clune's feet are quite dexterous. While standing on one leg it can use the opposite foot to lift up awkwardly shaped food to the mouth. It is a slow-moving animal and spends much of its time deep in the undergrowth of the forests of the northern island. If there are no ground-dwelling flesh-eaters, as is the case on the islands, many flying creatures may abandon their powers of flight and take up a ground-dwelling existence. In these areas most of the habitats on the ground may be occupied by animals whose ancestors once flew. On the southern island there are large areas of grassland to the east of the central mountain chain. These are grazed by a flightless pterosaur that is related to the clune. This is the wandle and it is quite a large animal. Like the carnivorous flying pterosaur ancestor has been lost. Its face has taken on the appearance of one of the sprintosaurs because it must accommodate a similar tooth pattern and jaw mechanism to allow it to eat the same food. Its specializations are similar to those of the terrestrial pterosaurs, such as the flarps of the Ethiopian realm. Many species of wandle exist at different altitudes between the mountains and the plains, and they all eat slightly different foods, the tall grasses of the lowlands, or the shorter grasses of the foothills. One species lives even higher up and eats alpine vegetation. They are all slow-moving creatures. With no large meat-eating animals present, they have not evolved defensive mechanisms such as armor, and have no need to be physically adapted for speed. The appearance of such an animal is always rather bizarre because it seems so unlike anything that exists under the normal environment constraints that influence animal life over the rest of the world. Herds of wandles roam the grasslands of the southern island in leisurely moving, unconcerned herds. From an evolutionary point of view they have reached a final stage. Any influx of animals from other realms would now be a disaster for them, since they have evolved in total isolation. They are low in intelligence, are not adapted in any way for defense against predators, and could not outrun a meat-eater if they happened to meet one. Nor could they face competition from the more efficient grass-eaters that exist elsewhere. Scattered across the vast ocean that covers almost half the globe, is a multitude of islands. These are not fragments of any continent, but have grown completely independently of Gondwana. They have appeared mainly through volcanic action, where an underwater volcano has reached the surface and cooled. The flanks of these islands are further extended by reefs built up by corals and other sea creatures. Belonging to no recognized zoogeographic realm, this array of islands is described here as part of the Australasian realm. At the same time as the dinosaurs developed to be the most significant animals on Earth, other creatures evolved to dominate. The seas. A group of animals of some importance were the ammonites, cephalopods that were encased in coiled shells. The shells consisted to empty air chambers that could be used by the animal to regulate its buoyancy. The ammonites evolved into many shapes and sizes during the Mesozoic period and are commonly found as fossils in rocks that date from that time. The coconut crab is an unusual ammonite in that it can spend much of its time out of the water crawling about on land. On many of the tropical islands of the ocean it can crawl up the beach and eat coconuts, and even climb trees to find the nuts when there are none available lying in the sand or washed up on the shore. The coiled shell of the coconut crab is flat on the bottom, providing a skid-like surface that allows it to be dragged over the sand. There are 8 tentacles. The 4 at the rear are broad and very muscular. They are used for pulling the animal over the ground and up coconut palms. The front 4 tentacles are long and delicate, allowing the ammonite to reach for a coconut. The eyes can focus both submerged and out of the water. Coconut crabs usually come ashore at night when it is cooler, and dawn finds the beach criss-crossed by their distinctive trails. When new islands appear above the surface of the ocean, their colonization usually follows a standard pattern. The initial living things to grow there are plants, germinating from seeds and spores born on the wind. The first animals are always insect, again because they can be blown on the wind from distant continents. The first vertebrates to arrive are the birds and pterosaurs, winged creatures that are able to fly over the intervening ocean areas. Very often these winged creatures give up their powers of flight and take up a ground-dwelling existence, eating the plants and insects on an island that is free from any dangerous predators. The shorerunner is just such a pterosaur, found on one island group near the equator. It lives mainly on the beach, running here and there catching shore creatures, or pecking about in the fermi undergrowth for small reptiles and insects. It is also adept at climbing trees, using its long fingers and toes, and can run nimbly along branches using its atrophied wings for balance. The islands are no more than about 5 million years old, suggesting that the shorerunner's ancestors must have arrived since that time. From the flying ancestors, several species have developed to populate the groups of islands, all with slightly different shapes and sizes and differing eating habits. The shorerunner is a major predator of the coconut crab. Should the ammonites linger too long over its coconut so that the sudden tropical dawn finds it on dry land, it will be set upon by a flock of shorerunners and torn to pieces. Other prey consists of burrowing insects winkled out of tree trunks by the long jaws. The shorerunner climbs trees nimbly, balancing with its atrophied wings. By far the greatest area of the planet Earth is covered with ocean water. Compared with the land areas, however, the ocean is quite barren. It is largely a cold and dark place, with prolific life appearing only in the uppermost few hundred meters, where sunlight can penetrate and support a flora of drifting algae. With an average ocean depth of 3,800 kilometers, this topmost fertile layer does not represent a very large proportion of the whole. Animals also live in the chill dark ocean depths, feeding on organic debris raining down from the productive layers, but they are not numerous. When the dinosaurs first evolved in late Triassic times, all the landmasses were fused into one supercontinent called Pangaea. The rest of the plant's area was covered by one continuous ocean called Panthalassa. The division of Pangaea and the separation of all the continents has meant that Panthalassa no longer exists, and the Great Basin that once occupied it has been shrinking ever since. Even so, its remnant, the ocean basin that stretches between the eastern end of the Palarctic, the Oriental and the Australasian realms and the western flanks of the Nearctic and Neotropical realms, still covers almost the globe. The other ocean areas are new, having grown from rift valleys that ripped the supercontinent apart. The Tethys has gone now, swallowed up by the movements and collisions of continents along the southern edge of the Palarctic realm. The continents are awash at the edges. The continental edges are never at the shorelines of the landmasses, they usually lie far out at sea. The resulting shallow shelf of land is called the continental shelf and may be as deep as 100 meters. Thereafter the bottom topography drops off quickly and the seabed slopes down to the abyssal plain, the surface of the oceanic plates. Deeper portions still are found in the oceanic trenches, elongated indentations in the ocean floor where one plate is being swallowed up beneath its neighbor. Most plant and animal life is found on the continental shelves, as the seabed here is within the zone illuminated by the sun. The shelf is usually narrow along continental edges where an oceanic plate is being swallowed up, and broad where the continents are moving apart. In the late Cretaceous period, as the last parts of Pangaea broke up, the shelves oceans have no well-defined zoogeographic realms. The great water areas are continuous with one another and have few barriers to migration. The waters of the world's oceans are in constant circulation, driven by the force of the winds across the surface. At certain places, particularly where the prevailing wind is blowing off the land or parallel to the coasts, the strong swirling currents bring cold nutrient-rich water up from the deep ocean floor. These areas of upwelling are found off the west coasts of the Nearctic, Neotropical and Ethiopian continents. The nutrient-rich water combined with the warm sun gives rise to blooms of floating plants in the surface waters, bringing in great shoals of feeding fish. Huge flocks of birds and pterosaurs also congregate in these areas and they hunt the fish. One of many types of pterosaur that have evolved a fishing way of life is the soar. It can hover for long periods over likely ocean areas, looking for signs of fish shoals near the surface. When a shoal is sighted, whole flocks of soars settle on the surface, and start to fish by dipping their long heads and necks quickly under the water. The animal itself is never fully submerged. After gathering a full crop it takes off again, rising clumsily into the wind from the wave tops and flying unerringly back to its nesting island. While it is hunting in flocks in the open ocean, the soar occasionally falls prey to the bird-eating plesiosaurs. The soar nests in flocks, forming rookeries on rocky islands. Hunting trips may take several days, after which the adult brings a crop full of fish back to feed the young. It is graceful both in the sky and on the water. While swimming, it holds its wings above its back, never wetting them. Only the head and the long neck are plunged underwater. A windswept chain of rocky islands rises above the green and white swell of the Southern Ocean. On the rock pinnacles, above the height at which waves surge and break, lie a number of glossy shapes, basking in the distant watery sun. These black and white creatures flop around clumsily, seeming to wobble on their bellies, pushed along by their stubby limbs, apparently quite incapable of any fast or graceful movement. Yet, when they reach a cliff edge, they rise to their hind legs and plunge head first into the foam. There they are transformed into elegant streamlined creatures, turning and darting, chasing after the shoals of fish that the fishing. Animals do not need to travel long distances to find them. The plunger is a fishing pterosaur that has lost its powers of flight. Its wings are still present but modified into hydrodynamic organs that allow it a mobility in the water that its ancestors had in the air. Layers of fat have built up under the skin, and these not only insulate the animal from the chill waters but also give it the streamlined shape that allows it to swim easily. The plunger's lungs have special adaptations to withstand the great pressures found at the depths at which they hunt their food. A development of the wing membrane between the hind legs and tail has produced the plunger's powerful swimming paddle. The swimming motion is augmented and steered by the wings, which are strong flaps of gristle. Fatty insulation is reinforced by the sleek pelt of fine hair, with its striking black and white pattern. For all its aquatic adaptations, the plunger still needs to come ashore to breed. It nests in vast rookeries on isolated rocks, but only in areas where the nearly ocean currents ensure a constant supply of fish. In the Mesozoic period the reptiles established an early mastery of the sea. Among them were the ichthyosaurs, which were the most well-adapted sea reptiles of all, with their fish-shaped bodies and tails. These no longer exist, having become extinct and been replaced by the lizard-like mosasaurs during the Cretaceous period. The turtles, slow-moving shelled herbivores, were also successful adopting a marine existence. The other main line of marine reptiles was the plesiosaurs. These quickly evolved into two main lines, the pliosaurs, and the elasmosaurs. Both types still exist in the modern oceans. The largest marine reptile alive today is the whelk, a pliosaur. The whelk cruises the oceans of the world, but where its ancestors fed on ammonites and squid and other cephalopods, this pliosaur consumes much smaller creatures. During the Cretaceous period, the shallow seas over the continental shelves produced vast volumes of plankton, tiny animals and plants that drifted in the warm nutritious waters. The shallow seas are not so extensive nowadays, but the plankton is still there. The whelk feeds on it by swallowing great volumes of water and straining out the plankton through its thousands of tiny teeth. The huge pliosaurs developed specializations that enabled different foods. The whelk consumes the ocean's plankton. Its teeth have become thin, fine and tightly packed, forming a sieve structure along the jaws. A voluminous pouch has developed beneath the lower jaw. The pouch is filled as the whelk opens its vast mouth. With the mouth closed, the pouch collapses, forcing the water out between the teeth and straining the plankton from it. Sea birds wheel over the green ocean, concentrating their attention on a shoal of fish feeding in the surface waters. One by one the birds dive, splashing into the depths and surfacing again with their catches. Suddenly a great turmoil churns up the water, and in a cloud of spray, pointed heads on long thin necks burst from the surface and shoot skywards, snapping and snatching at the wheeling flock. When they subside once more into the sea, the flock of birds has scattered in panic, and many of their number have disappeared. The necks belong to bird snatchers, the specialized, bird-eating elasmosaurs. In appearance they are very similar to conventional elasmosaurs that have existed for the past 100 million years. The seas have remained relatively unchanged, as has the fish population, and so the elasmosaur shape has proved a successful and long-lasting one. The main adaptation evolved by the birdsnache is its ability to catch sea birds. It lives chiefly on fish, but now and again a school of bird snatchers will work together to seize a flock of birds from the sky. With necks held back they approach an area where birds are fishing. Then they all break the surface at the same time and thrust their necks quickly upwards, each one grabbing a bird from the wheeling flock. The conventional elasmosaur shape is evident in the outline of the birdsnache. There is a bulbous, streamlined body with paddles for limbs, and a shortish tail with a vertical diamond-shaped fin. The neck is extremely long and flexible and consists of more than 70 vertebrae. The birdsnache's jaws are long and narrow, armed with pointed teeth that are angled outwards. This has been the shape of the elasmosaur head and jaws since Cretaceous times and, like the ancient elasmosaurs, the birdsnache lives mainly on fish. Its jaws and teeth, however, enable it to also catch birds. The pelorus is a small pliosaur and, like its relatives, it feeds on ammonites. This is the only type, however, that has the ability to attack and kill the largest ammonite of the oceans. It hunts in the warm, placid waters of the doldrums, where its prey is most abundant. There is an oily swell, and dotted here and there are the floating bulbous shapes of kraken shells, their long tentacles streaming out just below the surface, passively entrapping any small creature that happens into their entangling fibers. A splash. And a spray of water. The tranquil scene is shattered by a frenetic burst of activity around one of the bobbing shells. A pelorus has broken the surface and is wrestling with a kraken, struggling to reach its vulnerable parts. The weak tentacles loop and coil out of the water, trying to entangle the attacker, but they have little real strength. The pelorus clambers over them, wriggles through their coils, and finally plunges its sharp jaws down into the fleshy head. Again and again it stabs, until at last the tiny brain is destroyed. The writhing tentacles gradually become still, and the pelorus begins. The air seeps from the shell's chambers and the massive corpse sinks to the depths. The pelorus is one of the smallest of the pliosaur group. It swims by means of its paddle-shaped limbs and the flukes on its tail. It is not a very fast swimmer, but it uses its long neck and narrow pointed jaws against its main prey, the enormous floating kraken. The pelorus is immune to the stings of the kraken, but it could easily become entangled in the tentacles and drown. Its method of attack is to swim swiftly up through the curtain of fibers and clamber along the upper surface of the arms until it reaches the head. There it can stab at the soft body found in the shell chambers until the ammonite is dead. The ammonites of the Mesozoic seas were mostly swimming animals that moved freely about in the ocean waters chasing small swimming creatures that they caught with their tentacles. In Cretaceous times they developed into a number of different forms. There were those with heavy shells produced in irregular coils, that spent their time crawling along the seabed. Others were freely drifting animals, filtering microscopic food particles from the water using very fine tentacles. This second trend has reached a pinnacle with the modern kraken. The shell of the kraken is truly enormous. The shell acts as a protective armor as well as float to keep the animal in the fertile surface waters. It has 12 tentacles that it spreads out around itself, and each of these has thousands of trailing fibers that are armed with stings and hooks. The whole arrangement forms a deadly net that covers an area of about 20 meters in diameter. The kraken will eat almost anything that becomes entangled in its traps, from microscopic floating plants, to fairly large fish. Many krakens often drift in the same area of productive waters, their floating shells acting as perches for migrant birds and pterosaurs. The internal structure of the kraken is a scaled-up version of the internal structure of any shelled cephalopod. The shell has a number of chambers, and the animal occupies the last one. As the kraken grows, it produces more shell, moves forward and lays down a wall to create a new chamber behind. A blood vessel connecting all the chambers controls the air pressure and hence buoyancy. The 12 tentacles with their trailing curtain of stings and hooks radiate from the mouth at the shell's entrance. The kraken's tentacles are used for catching animal and plant food. The trailing fibers with their hooks and stings are evolved from the suckers found on the tentacles of its ancestors. When the prey is caught, it is passed to the mouth along the tentacles by muscular contraction. The air-filled chambers of the kraken's shell mean that it floats with the living animal and the tentacles just submerged. It moves by expelling waste water through its siphon, propelling the shell backwards and allowing the tentacles to trail behind. The world is a complete ecosystem. The grassy plains are grazed by rhodiophants and sprintosaurs. The fruits and berries in the trees of the tropical forests are eaten by crackbeaks. The twigs of the temperate and coniferous woodlands are browsed by brickets and coneaters. Mountain plants are scraped up and eaten by balaclavs and hanuhans. These plant-eating animals are, in turn, preyed upon and killed by fierce hunters like northclaws, cutlass-tooths and arborsaurs, and their dead remains are devoured by scavengers such as gourmands, and many of the pterosaurs. Yet the numerous animals described in these videos provide a selective and superficial account of life on the planet. In particular, the animals are nearly all vertebrates. Many millions of other species exist, especially among the invertebrates that have been only briefly mentioned here. The grasslands, forests, deserts and mountains contain a unique fauna of tiny creatures that are just as essential to the completeness of the ecosystem as are the big spectacular beasts. What would happen if the large reptiles were to become extinct suddenly, as has happened to the dominant forms of life many times in the past? What would develop to take the place of the large land-living vertebrates? Would it be the tiny mammals that scamper around the dinosaurs' feet? Or would it perhaps be the versatile and adaptable birds, or even some novel development of the reptile stock that we just cannot imagine? As the continents are now split apart and widely separated, it is possible that the world fauna that would be more diverse than at any time in the geological past. Whatever happens, life will survive and progress. For as long as our planet can support life, life will develop and adjust to the changing conditions.